Hello. Yeah, hi, good morning, class. Can you all hear me?
Good morning, sir.
Okay, good morning. Hi Rishabh. Hi, Raghu. Hi, everyone. I hope you all are doing good. So I think the people are still joining in. So we'll start in, I think around in next 3 4 minutes, we'll start the session. Okay. So in the meantime, anyone who would like to discuss any of their doubts, questions, feel free to do that. Sure, Rishabh. We'll do that again. So we will do that part of that how we find the z value. I'll show you that part once more.
Hello.
Hello, yes.
Mr. Ashwini this side.
Hello, yes. Yeah.
Sir, without using view, my
Mhm.
file is not working. matlab, any code is not working.
Can you, I mean, if you can you share your screen? Is it possible that you can share your screen and show me something?
Sir, I using my mobile.
Because see, view is basically a function that we use to see the data in the tabular format, right? Like if I show you something,
Okay.
I have a data set with me, empty cards. Okay, so if I do not use the view function, so what happen is it shows me that data over here in the console window. Okay, like
Okay.
now, but definitely if you just try to see the data over here, it is little difficult to see this, right? Because the data looks not very much structured. I mean, it is structured, but it is not in the form of the view we would like to see. So that is why what we do is we put it into the view function. So if I say view empty cards, now you will see the data, the same data now comes in the form of a table, which is much more readable. I can easily make out
Yes.
what
Yes.
value is where. So I mean, the prime use of view is only to see the data in this tabular structure, nothing else.
G. G.
Okay. So apart from that, when you do any modification or when you assign any variable, so in that case, what happens is that over there, what will happen is you will not be, I mean, getting any output. Say, for example, if I say I want to store this data of empty cars, I say I want to store this data into cars, and I say empty cars to this. Now this will not give me any output. It will just save the data of this empty cars into the variable cars. So if I execute this, so I should not get any output over here. Oops, spelling are wrong. So there we go. Right. So now if you see, I haven't got any output, but the variable would have been created over here by the name of cars. That is over here.
G.
Okay. Was this your doubt or something else?
No, sir, right now, no. Thank you, sir. Thank you so much.
No problem. Yes, we will be covering the apply function. So we will not be using apply right now. When we will be starting with the linear regression part over there, I will be showing you the apply functions over there. Because over there, we will be using the apply functions practically as well. I mean, I think yesterday or day before yesterday, I uploaded one more exercise on the your deep layers. I mean, you all can try that. If anyone has any concerns over that, you can let me know. We can discuss them as well. Okay, so I think we are good 10 minutes. Let's just wait for 2 more minutes. We'll start at 8:10. Okay, so just so that we can have as much people as we, I mean, to start up with the session. So we'll start at 8:10. Yes, Swati, please ask. Yeah, Swati, you can just type in your, I mean, copy paste the question over here. So this is reorder data first by cylinder column and then uh, why this and then wait. Okay. See, so the data set, I think the data set that we were using in this exercise was empty cars, correct? This was the data that we were using, the empty cars. Now, in this case, the question is asking that, the output that we have over here, I would like to see this output in the form like, where it is first sorted by, like what the question says, the data is sorted by the cylinder. Okay, so cylinder column. Okay, so let's just first, we will do step by step. So first of all, I need to put the library dplyr into, I mean, I need to put that package dplyr into my library and I will execute this. So now I have a package over here. Perfect. Now what I'll do is I will use the function arrange, right? So we have a arrange of function over here, and in the arrange function, then what we do is we put the name of that data set, that is cars. This is the data set. I want to sort first on the basis of cylinder column. So I will put cyl. Okay, now in this case, what will happen is the data will be sorted by the cylinder column in the ascending order, right? By default, it is ascending. So if I execute this, so let us take a look at this data right now. If you see, first of all, I have all the cars of 4 cylinder, and then I have all the cars of 6 and then 8, right? It is in the ascending order. Now what I want is like within these 4 cylinder, all the cars that I have of 4 cylinders, I want these cars to be sorted by weight in the descending order. I mean that what does that mean? That all the cars that we have in the 4 cylinder, they should be sorted in the descending order of the weight. Like 3.1 of 3.190 should come at the top. So this car Mercedes 240D should be the one that comes at the top. Correct? So what I'll do over here is I'll simply put up the another function over here, uh, the another variable over here by which what we will do is we will say descending order of the variable that is weight. Okay, so now if I execute this, so we will see the data is now sorted on both the variables. You see, for all the four the cylinder cars, the heaviest car is coming at the top. As we go down, the car is getting lighter and lighter. And then we move on towards the 6 cylinder car. Again, we can see over there, the heaviest cars are at the top, and as we go down over here, the car weight is decreasing. Am I clear, Swati, on this?
Hello, Amit. Actually, the question was that we have to first put a cylinder column
Hmm.
and not in order, but weight column only in descending order. First, we have to reorder the data. First, cylinder column should be there, following weight column in descending order.
Okay, so you want, okay, so and then no, so the question says reorder the data first cylinder column and then have you written this
Yes,
question?
and then weight column in descending order.
So I mean this is what we have done over here. So I mean if you're asking about the Reordering is something where you want the select column that you use, right? So what you do is you can put select over here, okay, and then what you want is this is the data set that is empty cars. Now what I can do over here is which column do I want first? I want the cylinder column as to be my first, right? So third, then I have the second, okay. Oh, sorry, first I have the second column and then the first column. So 2 comma, we can say C, and in this I want first 2, then 1, then what I want is this is 1 3 4 5 6 7 8 9 10 and 11. Okay, so we have 11 columns, so this will become 3
After
2
cylinder column, wait column.
this empty cars. Right, so if you see now the data is in this, I have first the cylinder column and then all the data coming over here, and then you can simply put it into the range. This data will be arranged by DESC weight. Okay. It is not found. Okay, so this is done. So you have all the data first, the cylinder column, and the data is then sorted by the weight. So heaviest car is coming at the top.
Yes, yes, okay. Select function is there in deploy.
Yes. Yeah.
Actually, I was getting error that select function is not found in deployer like that. So I'll try it again.
Maybe you might would have used the S in the capital. That could be one of the reasons.
Okay, okay. Thank you, Amit.
Okay. So Raghu, I mean, basically the dplyr package, sorry, the tidyverse package is something that is used for, that is something that is again used for the data clarification, the cleansing, when you have to do some more like, when I can say appending of the data, sort some columns here and there. So that is where we use the tidyverse package. So table structure, it is used to change the table structures and clean the table structures. So for that, in which ways we can make use of the joins also and R bind, C bind functions as well. So that is why I mean tidyverse is something that is we will not be touching upon. And tidyverse is also a package that it's a very big package. It by default installs the dplyr package and other associated package with itself over here. Okay, tidyverse. So basically, like the word we have universe, this is tidyverse. So basically, it will all the packages which are related to data cleansing, data modification, all the different packages will be kind of installed within this tidyverse package. Okay, and so in that case, you will not have to install the dplyr package or any other package separately. Okay, so let's move ahead with the session today, right? So, like in the last session, we all started with stuff that was the statistics, right? Where we understood what are the various type of different the terminologies that we use in terms of statistics, right? Well, what we did was we used a term that was descriptive statistics. I hope all of you are aware. Maybe like what I can do is I can give all of you a quick refresher on that so that we all are on the same page. Just give me a moment. Okay, so I guess all of you remember this one. So this is a slide that we were covering in the last class where we understood what is a sample, what is a population. Are you all are you all aware with these terms? What is sample and what is population? See, before we move ahead with this, I would just like to tell you something over here. In the statistics, basically, when it comes to statistics, how do we actually work? So let me tell you. So many a times, what will happen is like just what I'll do is I'll open up a notepad. So, understanding this part is very, very important. And we will be discussing this thing in a lot of detail as well as we will move towards the hypothesis testing and all. But just before that, I would like to clear that, so that this is something that is clear into your mind. Now, what happened is, like in statistics, there are two ways by which we approach the problem. There are two things. One is called as, you have a population. Okay, you have the data of the population, and now the population is so big on which you want to give some insights, or maybe you want to do some analysis on that. So what you can do is, like, since the population is too big, you cannot actually, do the analysis on that complete data. You will take a small portion out of it, and then what we will do is, whatever result you will get on this sample, right? This is a small sample that you would have picked up. Whatever the result that will come on the sample, you will say that, the same thing applies to the complete population. Correct? Like, like the case that we discussed, that if I want to calculate the average salary of an Indian. So in that case, what I will do is, since I cannot go to every individual and ask their salary, what I will do is I will take a small portion of that people, right? I mean, definitely the sample has to be of a good amount where we cover all type of people in it. And then what I'll do is I will calculate their average salary, and then I will say, this is what the average salary of all the Indians is. Okay, is this point clear? Is this the first scenario? Is it making sense? This is the first case, in which what we are saying is, we are picking some data from the population, and whatever we get over there, we define on that over there. So now the second thing is, okay, so Bhuvneshwari, I mean, we do not have something like as it call as, like for example, us how we define what is there is as such no rule or formula that you will get, that how you can define that sample size. But there are multiple ways by, by which you can conclude that whether your sample was correct size, sample size, and analysis was correct or not. There are multiple ways of achieving that, and we will also be discussing them as well. Now the second case is, over there what we do is, now something opposite of this will happen. In this case, I didn't knew what is happening on the population, but I had to, find that number by taking a sample, correct? Now in the second case, what will happen is, you will have a general notion about the population. You will have a general, you will have some information about the complete population, and on that population what you will have to do is, you will have to prove that whatever we are saying about the population is true. Okay, and that will again happen by taking a sample. Now the example of that is, say for example, I say that, like, the example that we discussed in the last class, the Maggie example. Okay, now in the Maggie, there was that the lead, the controversy that happened, where it was said that, Maggie, all the food items should have less than 2.5 parts per million lead into the food items. Correct. Now this was a general notion that, this should be applied and is applicable on the entire population. Now how will I justify it that, that Maggie is actually having the lead as less than 2.5 ppm, right? In that case, again, I will be taking a sample of the Maggie, right? Because Maggie would be producing 10 million packets of Maggie every day. They would be, 10 lakh packets or 20 lakh packets of Maggie every day. It is not possible for anyone to actually analyze each packet of a Maggie and then say, okay, whether the lead was higher or it was lower. What you can do is, you can just pick up a random sample out of it, and then you test on that whether, the lead is higher or lead is lower. And then if it comes higher, you will say the Maggie production is not as per the regulation, and if it comes less than 2.5, you will say yes, the Maggie is producing the products at the as per the correct regulations. Is it making sense? The two things, in the first case, we didn't knew what the population, how the population is behaving. We took a sample to explain that. Now in the second case, we know that how the population should, how should the population behave, but again we are proving that by taking a sample from there. Making sense to all of you, the two things? Anyone having any confusions over here? Any question, any doubt? Okay, perfect. So now let's move ahead and we will be talking about the the normal distribution, right? That's something that we were discussing in the last class as well. So I would like to ask you guys, what did we understand by the term the normal distribution? Anyone who remembers what normal distribution is and how it behaves? Right. So Rishabh, you say bell curve, Raghu, mean, median, mode, all are same, correct? So you both are correct in that understanding, right? So normal distribution was something, which looked like this, where we said that the data that we have, okay, the data that we have, in that data, all the points are normally distributed. Normally distributed means if I break the data into half, equal number of data I will have on the left hand side and equal amount of data I will have on the right hand side. As the data will increase, what will happen is I will have my as we will go more on the right hand side, my values will increase, and as I move on the left hand side, my values will decrease, correct? This is something that we understood by the normal distribution. Like for example, if I have a class of 100 students with me, right? Say suppose if I assume that all the students who are sitting in my class right now, you all are 30 plus students that we have in this session, correct? Now if I want to assume that you all are normally distributed, what will that mean is that all the 30 students, I have equal number of students who are of 20 years, equal number of, I mean, then students who are of, say, suppose 40 years. Then I have equal amount of people who are of, say, suppose 25 years. Then I have equal amount of people who are of 35 years. Then I say I have equal amount of people who are of, say, suppose 30 years. Hello? No. And same way it happens from this side as well. So the number of people we have on the lower side, the same number of people we have on the higher side as well. So this is something that we understand by the term normal distribution, correct? So data which is normally equal number of data on both the sides of the center point of the data. Now this is something that is called as the normal distribution. Now what we'll do over here is, now in this normal distribution, I told you something about the empirical formulas. Does anyone of you remember that empirical formulas? The empirical values, right? Not the formulas. Basically, they were the values that we discussed upon, right? So 68%, 95%, right? So these were the values that we discussed upon what these the empirical values were. So let me ask someone, right? So I will be asking the questions to any one of you over here randomly, just to understand that how much they have understood that part. Okay, so Sushma, can you explain like what do we mean by the first empirical value, that is 68%? Now, Sushma, can you hear me? Okay, anyone else who would like to pitch in? Sahil, what do we understand by the term 68%?
It's the first sigma.
It
First
basically
sigma.
Mm-hmm.
it basically means that when we're talking about 68%, it talks about -1 sigma to +1 sigma, and it means that the 68% of the data lies under that area in a normal distribution.
Correct. Right. So when we have a data, so you're 100% correct. So when what we say is +1 sigma and -1 sigma. So what was that? Plus 1 sigma and minus 1 sigma. So let us hear from someone else now. So maybe I could ask Sanjana. I mean, would you like to take a opportunity to speak? What was the one standard deviation or maybe 1 sigma and 2 sigma? What was that? See, so I'll just repeat it for the people who are still a little bit confused, right? So we discussed something about the mean values and we discussed something about the standard deviation. Correct. So what was standard deviation? Standard deviation and mean, what they were. Mean was basically where the center point is lying, where the center point of where the center point is lying. Correct. Now, see, you all have to understand one thing. Whenever we talk of the statistics, we do a lot of assumptions, and we always, with the help of statistics, we try to you know predict some values, I will say. Correct. So if the people who are not still clear on the mean and standard deviation, I will just repeat for them, like in a very layman's language, what do we actually understand by this. Now mean value is, like, suppose this is the class of 35 students. I say that the mean age of all the people that we have in this class, the average age of a student is, say, suppose 30 years, right? So this is what I'm taking as an average. This is the average age of my class. Now, average age means 30 years. So this means that there will be people who are higher than the 30 also, and there will be people who are younger than 30 as well, right? This is what we understand by the term average. And average or mean, they mean the same thing over here. Now, standard deviation means that how much variation do you have in the data around that mean value, right? So that means if you pick any student, what do you expect his age would be? Okay, so if I pick any person from that group, I know that average age is 30 years, and say suppose standard deviation is 2. So standard deviation will be that how much variation do we have around that mean. So people are plus 5 minus 5, right? So people lie in the range of 35 to 25. That is what my standard deviation is. So that is the variation around the mean. And say suppose the variation, my standard deviation is 5, so it will be plus minus 5. Okay, plus minus 5 means that a person's age could be plus 5 or a minus 5. That is the range in which that age would be lying. But it doesn't mean that it is the maximum or the minimum. This is the first deviation that we are talking of. What we can do is we can increase the standard deviation by our own ways as well. We can increase the standard deviation. Now this is the one standard deviation that we are talking of over here, 1 ST, first standard deviation. And then what we have is we have two standard deviations and we have three standard deviation as well. What does two standard deviation means? What does two mean? Two will be 2 into that previous standard deviation, that will come as plus minus 10. Okay, and same way 3 standard deviation will become plus minus 15. Correct, because 3 into 5, that will give me 15 over here. Are we all clear? Anyone who is still having any doubts over here? See, class, I am repeating these things again and again because these all things are very important for all of you to understand. Because if you will understand these things, you will enjoy this data science more. And if you will not, so you will always be, a little bit confused at why such number is coming up in front of me. Okay, so that is why I'm reaching out to everyone to make sure that you all are getting this concept. Okay. Now, what we do is we can actually plot this thing onto our this normal the normal distribution curve that we have created. So if this is my mean value, right? Say suppose this mean value was the mean value that we calculated was 30. So this mean value will come as 30 over here. Okay. If I'll go on the right hand side, my value will increase. If I'll go on the left hand side, my value will decrease. So if I move one deviation ahead, what will this value be? What will this value become? This will become 35, right? And if I go on the left hand side, what will this value become? This will become 25, right? And similarly, if I move 2 standard deviations ahead, that means I am reaching towards the point of 40. And similarly, if I move minus 2 deviations, it will become 20. Correct? Are we all clear up till here? So no Rishabh, so standard deviation can be for any data. It can be for any data, but in the normal distribution, because all are, the algorithms and all are equations that are created, they are created based upon the standard data, like how that normal standard data should be in order to get the exact result. So standard deviation can be found on any kind of a data. It can be normally distributed, or it can be a skewed data as well. Skewed data means a data which is like like this. The mean is lying somewhere over here. So you have more number of people on this side and less number of people on this side. So on this kind of a data also you can find the standard deviation. Your data can be like this also, right? It just goes the other way around. So in this case, my mean will be here. So more number of people over here and less number of people on this side. So it can be for all the people. Okay. So now what we will be doing over here is, now this is the minus 25 and this is minus 20 over here. This is plus 5 and plus 10 that you get over here. Now, what we do is, like, now this was the case, this was the example that we took, this was the example of age. In the age, the average age will come somewhere around 30 years, right? And the deviation is coming as plus minus 5. Are we right? I'm right. Like, this is what I get over here. Now, if suppose this data changes, now I have the data related to the salary. In this case of salary, my average number will come somewhere around, say suppose 20,000. Say suppose this is what my average number is coming, and my standard deviation, say suppose that comes out to be 3,000. This number comes out to be 3,000. This is what I am getting from here, 2000 and 3000. Now, in this case, what will happen over here is that since my data is now, like over here we have a mean of 20,000 and a standard deviation of plus minus 3000, will there be any impact over here on the curve which I have created? Do I need to change this curve? Do I need to change the any relatively anything over here on this chart? No, right? Because the only thing that will change over here is, instead of 30, I will put 20,000, and instead of this 35, it will become 23,000. This will become 26,000. Same way, this will become 17,000 and this will become 14,000. So this is how the numbers will change. Now, basically, just because of this purpose, because we can have very small mean also, and we can have very big mean also. We can have very small standard deviation also, and we can have very big standard deviation also. So just so that we can standardize the data, we have something that is called as z-score. Okay, now z-score is something that is called as a term or a value for standardization. We use this z-score to bring the data onto the standard nature of data. And what do I mean by standard nature of data? In terms of standard nature of data, what we do is we talk in the context of one standard deviation, two standard deviation, like this. We talk in the terms of one and two standard deviations. We are not concerned about what that deviation is and what that number is. Okay. So now if I come over here, if I ask you that you have to, that the age was like, like if I talk of when the age was 30, okay, when the age was 30 and I mean, we had a standard deviation of 5, and now what I do is I put standard deviation as 5 over here. Now what happen is, say suppose I get that uh, how can I, what is the probability that if I pick a random person, his age will be, say suppose 35, right? I ask you this, what if I pick up a random number, what will be the probability that the person's age will be 35? So what we do is over there, we first of all figure out that of how much standard deviation range we are talking of in this data. Okay. Now, if you see, so in order to calculate that z-score, what we will do now is, now in order to figure out that standard deviation, so if say suppose, now I ask you all over here, if my mean is 30, my standard deviation is 5, how much in how much standard deviation this person is lying? Is it lying in first standard deviation or two standard deviation or three standard deviation? In how much deviation is this data lying over here? One standard deviation. See, even without Raghu, even without using the formula also, you could have tell me this thing, correct? I mean, your approach is 100% correct, but still, just to understand it better, because 30 plus 5, that gives me one standard deviation. So this data comes into the range of one standard deviation. So it is exactly one deviation away from my mean value. Am I right? The person whose age is 35, he is one standard deviation away from my mean value. Correct? Now, if I say there is a person, his age is 40, how much standard deviation is he away from my mean? How many standard deviation is he away? Two standard deviation. Correct? All of you can perfectly, you all can answer it. Now, the thing over here was my data was very simple. When I say simple, huh? So when I'm saying my mean is 30 and my deviation is 5, right? So these are the numbers that we are talking of. When we said this, you all were very easily able to tell me that how much deviation I am away from that mean, correct? Now say suppose I say this is the mean, this is the standard deviation, and what I do is I pick up a person whose age is 33. Now I ask you that how much standard deviation this person is away from the mean. How will you tell me? Right? So now if I ask you that the person that I have picked up, his age is 33, how much standard deviation is he away from that mean value? Right? So will you be able to tell me the answer? No. No. So it is below one standard deviation, Nandini, right? So I want to see the exact deviation, that how much exactly he is deviated from that mean number, correct? He is less than 1 SD, right? 1 SD is equivalent to 35. The maximum range of one standard deviation is 35. But this person is of 33 years. So I want to know exactly how much is he away from that mean. So in order to simplify that thing, right? In order to simplify that thing, we had this formula of z-score. Okay, so what is the formula of z-score? Let us see that. Okay, I will just open that screen so that you can all see that formula. Okay, this is what that formula is, right? So like this was one formula that we saw yesterday, which was a very heavy and a complex formula, which is definitely not easy to use. So we had this formula over here, right? So just read this over here. Z value or standard score. What is this? How many standard deviation an element is from the mean, right? If I pick any person whose age I know, how much standard deviation is he away from that mean value? Now, in order to check that thing, the formula is very simple. X minus mu. X is the number, that is 33. So I will say equal to 33 minus 30. 30 is my mean, divided by the standard deviation, that is 5. So I get 0.6 deviation. Okay, so this person is exactly 0.6 deviations away from the mean. Are we all clear on this? So if I pick up this number, so this person is 0.6 deviations away. Okay. Now, this is what we have done is we have found the standard deviation. How much standard deviation is he away from the data? Now you all do this question. You all have to find out. Okay. So basically, what I say is that I have, say, suppose, let me take an example of paracetamol, right? Like in the paracetamol, so we again, the reason I am giving this example is because this is something very good stuff that we will be doing with this example. So, in the medicine, there is always a fixed concentration of the different salts, correct? Like if you buy a tablet of, say, suppose paracetamol, so it will be having that, this medicine has 500 mg of paracetamol in it, correct? Now, if say suppose when the tablet is being manufactured, they put less amount of paracetamol in it. It has to be 500 mg, but they ended up putting a lesser amount of a paracetamol. What will happen to the medicine? It will become less effective. Am I right? Your doctor prescribes you that you have to take a tablet which should have 500 milligram of paracetamol in it, and you go and you buy that medicine, but the chemist give you a faulty tablet, and you realize that in that tablet the paracetamol was only, say suppose 450 and 450 mg. Will that medicine be as same effective as the one would have which would have been having 500 mg? Will the effect be same? No, right? So you have taken lesser amount of a paracetamol. And if the opposite of this happens, if by any chance in that tablet the paracetamol, the amount was not 500 mg but it was 520 mg. If that amount was 520 mg. Now there can be some harm effects of this medicine, because the doctor prescribed me for 500 mg and I am taking 520 mg. So higher dose can actually lead to some side effects to my body, correct? Now same, so in the pharmaceutical industry also, there is a lot of statistics that is used in order to do and test that whether the tablets are having this, exact amount of that, these salts that are mentioned or not, right? And so this is the example that I'm saying. Say suppose, the average quantity of that the paracetamol in a tablet is 500, okay, and the standard deviation that we found in that was 10 10 mg. There was a standard deviation of 10 mg. Now all of you calculate the z score. What will be the z score for a medicine of, say suppose, 493 mg? What will be the z score for 493 mg? So I would like to have the answers over here from the people, so all of you please, I mean, I'm sure that all of you will be able to answer it, but I would like that the people I name, they should try to answer this. Okay. Oops. So all of you already given it. Okay. 0.7. Okay. So Rishabh says 0.7. Sakshi, you say 0.7. Vishal, perfect. Others, all of you have to calculate this and put your answers over here. Reena, right. Nandini, correct. But are you all correct? Whether I get positive or negative? See, most of you have given the number as positive, but the answer will be negative, right? Correct, right? The people who are starting in the given 0.7, they all are wrong in that in their answer, right? So it will be 493, right? 493 minus 500 divided by 10. Correct? This is what that calculation would be. Oops, did I put something? Oh, instead of the division, I gave multiplication. So minus 0.7 is the z score that I will get over here. Okay. Anyone? Any doubt up till here? Correct, Bhavani? Okay. I would like to Anchal, Nitin. Are you all clear on this?
Hello. Solution. Hello.
Rishabh, I'm not able to hear you. What you are saying?
Hello, hello.
Yeah, Rishabh, your voice is not at all clear. I mean, it's very distorted. You can put in the chat in case you have something, because your voice is not at all understandable. Okay, so in the meantime, I'll just move ahead now. So if the people who are clear with this Z score, now they will be able to understand the part that we are going to do ahead on this. Now, we generally do not use the Z score. So Rishabh, Z score can be checked in the R also, and it can be there are tables over here, right? So there are tables that we have. The Z table, if you will Google search, you will be able to download the Z tables from there, and you will be able to find that. I'll just show you that. You just have to write on the Google that you want to see the Z tables. Okay. See now exactly if I tell you something, this questions that I gave you, right? These questions over here and these questions over here. The idea of these questions to give you was so that you can just calculate the Z score. Okay, this was the idea so that you can understand that how much what standard deviation is and how is it telling us, right? When you said minus 0.7, minus 0.7 means the data will be lying on the right hand side or the left hand side. Which side the data will lie? Will the data lie this side or this side? Left or right? Left, right? Because the number is coming in negative, so that is minus 1 deviation, minus 2 deviation, so this is minus 0.7 deviation, so the data will come on the left hand side. This is the data, this side the data will lie. Perfect, right? So now you all are able to grab it. Right. Now what we do over here is, the question will never come like this. The question will never be asked to you that what is the probability that person is of 32 years, or what is the probability that the tablet has the paracetamol as 493 gram. No, the question can never come like that, because whenever we make this, the normal distribution curve, it is made for a continuous data. Okay, what do we mean by continuous data? A data which has infinite values in it. Correct? Continuous data is something that has infinite values between 2 points. When I say that my age is 30 and say suppose I say Rishabh's age is 27, so between 27 and 30, you will say that okay Amit, there are three ages that are lying: 28, 29 and 30. No, right? There will be a lot of people who will be of 27.1 years, 27.2 years, 27.3 years, 27.4 years. Am I right? So the age over here is continuous, correct? Because every second the age of the people is changing. Every second my age is changing, and every second the age of Rishabh will also be changing at the same point in time. So same will be the case for the people who are in that the bracket between 27 to 30. So that means I can say that there are infinite people who are having the age between 27 to 30, correct? Right? So this is what we understand by the data which is continuous. Okay, so when the data is continuous, right, and if I ask you what is the probability that his age will be 28 years, you cannot give that answer. Why so? Because there are infinite cases for that 28 number to come up. So that is why I cannot predict the age. Well, will the person's age will be 20 exactly 28? The probability of that will be 0%. Okay, because and the reason for that is infinite points. Now, what we do is, as per the empirical rules, there are some percentages that have been defined. Percentage that define is that under the part of 1 sigma, okay, plus 1 and over here on the -1, on this side of -1, as per the empirical formula it has been defined that the probability that a person's age will lie between -1 to +1 sigma is 68%. Okay, that means that if I pick up any person and I ask that will his age be less than 35, the probability of that to be coming as true will be 68%. I will be only be 68% sure that yes, his age will be less than 35. Okay, are you all clear on this? Okay. Similarly, these percentages are defined for the second deviation as well. For second deviation, it comes to be around 95%. Now, if I say what is the probability that the person's age will be less than 40, okay, now I am going two standard deviations ahead. So now I can be the more sure that okay, how his age, whether his age will be less than that or not. So I will be 95% sure in that case. This number will be 95%. And this 95 and 68%, they are divided into two parts, half over here, half over here. So 34% over here and 34% over here. Same goes for 95%. And when we reach to the point of 95%, we third deviation, we reach to the point of 99% in that case. Okay, so I'll just show you that chart. I mean, on the Google itself, so it will be much more easier for you all to see and relate to it. Okay, normal distribution chart. Okay, let's just see that. This is see. So let me just remove all these drawings. This is not very much clear, I guess, due to, I guess, the net issue or maybe something like that. See, yeah, so over here it looks much better. So can you all see this? Correct. So if you see now, this is one deviation, this is two deviation. Can you see it? They have clearly marked in this chart over here as well. So minus one deviation, plus one deviation, minus two deviation, plus two deviation. So within the range of one deviation, there is 68.2% of the data that is lying. Within two deviation, it is 95.46. And when we go to the third deviation, it becomes as 99.72%. Okay. And what is the overall percentage under this curve? What is the overall percentage under this curve? Under this curve, what is the overall percentage? 1, or we can call it as 100%, right? If you talk in terms of probability, that will be 1. If you talk in the terms of percentage, it will be 100. Right? So this is exactly what this normal curve, the normal distribution curve tells us. And how we now over here, what happen is, see, if the value will be under one deviation, you will be able to tell that, okay, this number is, 68%. And if it will be under two deviation, you will be able to tell that this number is, 95%. But if the deviations are different, right, like 0.7, minus 0.3, minus 0.4, so how will you be able to give that correct number in that case? So over there, what we do is we use the Z tables in order to tell that part, that what that exact percentage of people will be, following our criteria. So let us see that. Let us do a quick question on that basis of that. Let me show you a quick question and you all have to do that. Let's go. Yeah. So I think this question we did last time also. Just I will request all of you to do it one more time so that we all are on the same page. Okay, a company has 500 employees, salary of whom is normally distributed with an average of 40,000 and deviation of 6,000. Suppose you pick up a random employee from there, what are the chances he or she earns less than rupees 30,000. So how will we solve this question? So we have to find what are the chances that he or she earns less than 30,000 rupees. So what we will do over here is, first of all, we will find the z-score, right? How much standard deviation will that person be from our that mean value? So for that, what we will do is we will find the z-score, and z-score is x minus mu divided by sigma. That gives you minus 1.66. Now this is the z-score that we are getting. Okay. Now over here, what I'll do is, see, as a starter, I will say you should also create this chart with you. Okay, this is what you have. This is what the data is. This is where the mean is lying, which was how much? 40,000. This was 40,000, 40K. Okay, and you have found the z-score to be coming as minus 1.66. So if this is minus 1 and this is minus 2, so minus 1.66 is something that will lie around over here. Now we want to find out what is the percentage that the person will be earning less than 30,000, right? This is what the question is. If a person is earning less than 30,000, will he lie on this side or on this side? For chances that his salary is less than 30,000, will he be on this side or will he be on the left, this side? This left hand side, correct? This person will be on the left hand side, he will be lying. So we want to calculate this curve area, that how much percentage of data is lying under this area. Okay, and in order to find that, what you will have to do is you will have to use this z table in order to find that value, right? So you will be using z table to find what percentage of area is lying under that curve at any point in time, right? So you will be using z table, and when you will search the z table over there, so you will have to basically find the z table from the left. Okay, because in this case you are finding the area curve from the left hand side. If in case you are finding the area from the right hand side, so in that case you will search for z table from the right. Okay, in that case also the numbers will be positive also in that case. So if you just google search, right, if you just put on the google that z table from left to the left, right? So Rishabh, your question that you asked, you just have to google search it and you will be able to find that tables over here. Yep, so here we are, the minus values, right? So what was the value? Oops, did I click on? Right, so now if you will find minus 1.667, so over here we will be able to locate that minus 1.667 is over, or it was minus 1.66, right? This was it, but it was 0.485, correct? We can find that value over here, 0.485. Here is that value. Perfectly, we have got it. So the chances that his salary will be less than 30,000 is that will be 4.85%. This is the surety that we have, that his salary will be less than 30,000. Okay. Okay, so now all of you please do this question and find and tell me what will, from the same data, what will be the probability that that person's salary will be less than uh, say suppose 27,000. Okay, all of you do this question. What will be the probability that if I pick some random number, a random employee from the data of these 500 people, that his or her salary will be less than 27,000? Please do this question. So Rishabh says 1.74%. Awesome, you say 1.19%. So we will see who is correct. So it is 27,000, right? So others, let us see what answers do you all get. Vishal says 1.9. So all of you are getting different numbers. So Mozum and Subhakaran, you have got a similar number. Sakshi, you have gained 1.19. So what is the Z score that we have all got? What is the Z score? So the Z score is, okay, let us find this out. Over here, the Excel, I can find it. So 27,000 minus 40,000. And what was the deviation? 6,000, correct? 6,000. So minus 2.1667, right? So minus 2.1667. So if I'll come over here, minus 2 point, minus 2.16, that will be 0.0154, right? 0.015. Is it 2.1, right? 2.16 that we have got, right? So this is the number. I can see it. It is 0.154. 0.0154. So 1.5%. Correct? So Nandini, you are getting 39%. How are you getting that number? Raghu, 98%. Can you just share your thoughts how you have got to that number? Okay. So Nandini, you saw the wrong line. Okay, no problem. Yeah, I can understand. This is because the lines are, the numbers are very small written over there, so it can happen. Okay, so Raghu, you saw the right table. You saw the value from the positive side, I guess. As we have to see it from the left hand side. Now if you actually see that, I know, so that will again confuse you. So I'll not come over there. So okay, so are we all clear on this? Are we all clear on this? Okay. So now we have understood what this Z score are, what that normal distribution is, what that percentage is telling me. Now we will do something little more interesting over here, and that is central limit theorem. Okay, so I hope many of you would have studied this central limit theorem in their class. Not in their school, but probably in their BTech, if the people are from the BTech in the background. So we have the people from the BTech, so they would have been, they would have been. How much people do we have over here? Like the people who are from BTech, they might would have studied this central limit theorem if they would have their subject, random variables, stochastic processes. I'm not sure. Because in my graduation, I remember when I did my BTech, so we had this subject over there. Over there, we had this central limit theorem, and it was always a big mess to understand this. But yes, now I understand it well, and I will try to explain all of you as well, like what exactly the central limit theorem is all about. So let me just come to that central limit theorem. Yeah. So now like central limit theorem. So what is a theorem, right? When we say something as a theorem, that means that is something that is already proven. Okay, the person who would have actually given that theorem to us, he would have collected a lot of data, then he did his experiment and found some conclusion over there, and then he gave as a generic statement which applies to his finding that that this is what will happen if you do this, right? Like for example, we had a Pythagoras theorem, that means if you have a right triangle, the square of one side plus two side will be equivalent to square of the third side, right? This is something that we have seen and we all know it, that it will always come out to be as true. Now there is a small quick definition that comes and falls under the central limit theorem over here. Now, what is this theorem says that for almost all populations, right, any kind of a data that you have, the sampling distribution of the mean can be approximated closely by a normal distribution, provided the sample size is sufficiently large. Okay, can you all understand this statement? Let us see who can explain the statement over here. I mean, you can unmute and you can take a chance of that. Yes, class. So, anyone understand this statement that is written for almost all population?
Yeah, Sai here.
Yes, I am.
Uh, does it mean that if we have a large enough sample size and it includes all the variations that are there in the data, obviously excluding the outliers, so the mean of that sample will be uh, close to the mean of a normally distributed data?
No, no. So it is not. Your answer is not very near to the mean also. So I reject your hypothesis over here. Okay. See, let me try to explain you this. So this says, right, for almost all the populations. All the population means any kind of a big size of a data that you have. Okay. So whether you're talking about you have to calculate the average age of the population of India, you have to calculate the average salary of the population of India, or maybe in the entire world you have to calculate how many people are COVID positive or are COVID negative. So what this central limit theorem says is if you have a big population data with you, and then what you do is from the entire population you pick one sample. Okay, from that entire population you pick one sample, and then what you do is you find the mean of that sample. You will find the mean of that sample. So you took out one sample and you calculate its mean. Then what you do is you pick up another sample, and again for that sample if you will take out the mean, right, you note down that mean. So will the mean be different from the previous sample or will it be the same? Right? So please try to answer this. So what I do is from this entire population of India, I want to calculate the average age. So what I'm doing over here is I'm picking one set of 200 people. Okay, I picked 200 people. I calculated their mean age. Then I picked another 200 people and I calculated their mean age. Now, will the mean of these two groups will it be the same or will it be the different or will it be different? Right. So it will be different, right? So, I mean, there are high chances that it will be different. Now I pick up the third sample. I pick up a third sample of 200 people. Same size. I pick up a third example. I pick up a third sample. Now, will the mean of that sample will be different or will it be the same? It will be different, right? So now what this theorem says is that if you have a big population of a data, like I was picking one by one sample, I was picking one sample, then second sample, then third sample. Now this theorem says if you will pick a lot of such samples, okay, if you will pick lot of such samples and the mean values that you have calculated for each of the sample, that value will come as a normal distribution. Okay, if you will plot all the mean values that you would have calculated for the different samples that you have picked, it will come out to be in the form of a normal distribution. Now try to read this. Now this theorem says, just now read it. It will make more sense. And Rishabh, so now, like, if you would like me to explain you in Hindi, so what we are trying to do over here is कि हमारे पास एक बहुत बड़ा पॉपुलेशन का डेटा है, तो मैं उसमें से क्या कर रहा हूँ, एक एक करके एक सैंपल पिक कर रहा हूँ, राइट. मैंने एक सैंपल उठाया, फिर दूसरा सैंपल उठाया, फिर तीसरा सैंपल उठाया. सो इफ यू सी फॉर ऑल द पॉपुलेशंस द सैम्पलिंग डिस्ट्रीब्यूशन ऑफ द मीन, राइट, जो आपने सैंपल लिया, राइट, उसका फिर जो आपने मीन निकाला, ठीक है, इट कैन बी अप्रोक्सीमेटेड क्लोजली बाय अ नॉर्मल डिस्ट्रीब्यूशन. तो जब आप उसको किसी चार्ट पे प्लॉट करोगे तो वो आपका एक नॉर्मल कर्व की तरीके से बनकर आएगा. तो आपके कुछ सैंपल ऐसे होंगे जिनमें मीन बहुत कम होगा, कुछ सैंपल ऐसे होंगे जिनमें मीन काफी ज्यादा होगा, एंड लार्जली द मीन विल लाई इन दिस सेंट्रल एरिया. Okay, this is what the standard deviation is. So this is exactly what this central limit theorem also states. कि आपके पास डेटा जब बहुत बड़ा होगा तो उसमें आप सैंपल्स लोगे तो वो आपका नॉर्मल डिस्ट्रीब्यूशन के कर्व में रिप्रेजेंट हो जाएगा ऑटोमेटिकली. एंड वी विल प्रूव दिस एज वेल. हम छोटा सा इसके लिए एक एक्सरसाइज करेंगे in order to understand this thing कि does this actually happen also, या फिर उसने सिर्फ लिख दिया है यहाँ पे कि this is something he has written that this is what should happen, this is what will happen. We will try this thing out as well. Okay, now what I'll do is let's just move ahead. Now the second thing that he said was that now over here, if you will plot that, the basically if you have the different observations, okay, of that population, right, which was that entire data, so the data that you had plotted, the entire population, if that entire population had a normal distribution curve like this, and now when you have picked up the samples from there, right, when you have picked up the samples and calculated their mean, right, the distribution of sample means, that will come in the normal distribution, right, that data will come in the normal distribution. What is the difference between these two curves? What is the difference between this curve and this curve? Can anyone tell me the red and green curve? What are the two differences between these two curves? Because the answer lies in this visual over here itself. Right? So Rishabh, you say high mean, right? So the mean is higher, and someone said standard deviation, right? So these are the 2 points that we have to observe over here. So Ayush, you are right. So, and Yash, your point is also right. Red curve has high variance. The deviation is higher in the red curve, and the deviation is less in the green curve. Okay, as you see, the deviation is less in the green curve. Is this making sense to all of you? Right, Swati? And Swaroop, Sushma, Uma, are you all able to grab this? And I will show you this as well, right? Do not worry that you have to, and you do not have to learn these things as such. You should be just clear with this thing, like what these exactly the things are. Now because over here in this visual there is one more answer that lies in. That answer is that as you will keep on increasing the sample size, अब जैसे जैसे अपना sample size बढ़ाते रहोगे तो आपका जो standard deviation है वो कम होता जाएगा. Okay, what I mean by that is, I'll explain this in English as well. Like what will happen is, say suppose in the example of the population that I was giving you, I took a sample size of 200. Okay, now next time I repeat the same activity, and this time I take the sample of, say suppose 900. This time I took the sample of 900. Now if I'll increase the sample size, the standard deviation will reduce. The curve will become like this, right? So let me just recreate this. This theorem says that if you will keep on increasing the sample size, what you will actually realize is that the standard deviation will keep on getting reduced. If you will increase the sample size, it will reduce. You further increase the sample size, it will further reduce. The deviation, the standard deviation will keep on getting reduced as you increase the sample size of your data. Okay. Now, what I'll be doing over here is, so if you see over here, this is just the same example over here, that as you will keep on increasing the sample size, the deviation will keep on getting reduced. Okay, now how will that deviation be reduced? Okay, how will the deviation be reduced? For reduce of the deviation, there is a formula. That deviation is sigma divided by root n, right? Sigma divided by root n. What is sigma? Sigma is the standard deviation of the population. You see, this is the standard deviation of the population, and sigma x is the standard deviation of the different samples that we have taken. Now, if your sample size was of 400 and the deviation of the population was, say, suppose 20. Okay, say suppose I am saying the standard deviation of the population was 20, then what I did was I took a sample size of 400. What will be the standard deviation of that data, of that samples that I will be collecting? So the result will be 20 divided by root of n, right? Root of n is root of 400, that gives me 20, which will come as 1. You see, this is count 1. Now, if you further increase the, if you will further increase that, the sample size, say suppose from 400 you make that of 900. So in that case, it will become 20 divided by 30, correct? 2 by 3. So the standard deviation will become 0.66. That is somewhere the standard deviation will come out to be. Okay, so as this is how the standard deviation will be calculated, and this formula that you see over here is, this is also called as the standard error. Okay, this term that you see over here written, this is also called as standard error of the mean. That means the error around that mean will be of this particular value. So standard deviation of the sampling distribution of the sample is called as standard error of the mean as well.
अमित, मुझे ये समझ में नहीं आया। सो अभी मान लो कि अभी हमारे पास 1000 लोगों का पॉपुलेशन है, राइट? तो उसमें से हम पहले 200 ले रहे हैं, इज दैट व्हाट यू आर सेइंग?
Yes.
एंड उसके बाद हम
दोबारा
उसी में से फिर 400 ले रहे हैं?
नहीं, see what we are doing is, say suppose, see when you say so Nandini, I was speaking in English only. So basically, yeah. So the question that basically there's Bhuvneshwari, right? Bhuvneshwari, I'll just repeat that question. So her question was that we have a sample of 1000 people, and from that sample we are picking a smaller sample of 200 and then 400. Correct? This is what her question is. So now let me answer your question. So what we are saying is, first of all, when we talk of central limit theorem, we talk in the terms that the data that we are talking of is really huge. So 1000 rows will not be able to serve that purpose. I mean, it will serve it, but still, we assume that at least, I mean, with this, although with 1000 also it will work. I mean, it will not create a problem. So let me show you. So say suppose I will take your example only. I have a data of 1000 people with me. Okay. Now from this 1000 people, what I will do is I will pick up, say suppose 100 samples. I will pick up 100 samples from here, and those 100 samples, right? So one is sample. Please understand two things. One is sample and another is called as sample size. Okay. We should be clear about these two terminologies. One is sample, another is sample size. So sample is, I pick up one sample in which I picked up 100 people. That is called a sample size. Okay, so what I am doing over here is I am picking a sample, I am picking 100 samples. In each sample, so suppose I am picking 50 people. Bhuvneshwari, is it right? Are you able to get it? What I'm saying over here? So each sample of this 100 people, each sample will have 50 people in it. Okay. So what is the sample size? What is the sample size? All of you please tell me what is the sample size over here? Correct. Now the sample size is 50. So what this theorem says is, when this sample size of 50 and you have taken 100 such samples, if you will, and you find the mean of each sample. First you find the mean of first sample, then you find the mean of second sample, and then you find the mean of third sample. If you will find the mean of all these 100 samples, that data that you will get, it will come in a normal distributed curve. That is one thing. Is it clear? Okay. The second thing is, now in the first case, what I did was I took 100 samples and sample size was of 50. Now what I am doing is I am again picking up the 100 samples, but this time I am increasing my sample size to, say, suppose 80. I have increased the sample size to 80. Now I am taking one sample of 80 people. Is it correct? Now this theorem says if you will increase the sample size, the standard deviation will reduce. Okay, the standard deviation will reduce. Now the chart will come little over here. Now this deviation that you see, that has reduced. Okay, and how that deviation has reduced, for that you have this formula. Sigma divided by root n. If sigma is the standard deviation of the entire population, if you take a sample of 80, it will be root 80. If you take a sample of 50, it will be a root 50. So this is what that standard deviation of that data would be. Is it clear now? Yes, Bhuvneshwari, others, Nandini. Correct. So now if you will see over here, see now you can see this same thing over here. Now this is in the visual format. You know what I'm doing over here is, yes, predicts. If the sample size will increase, the standard deviation will increase. Now you can see that same thing over here. When I had a sample size of 1, this is how the data was. When my sample size increased to 4, this is how the data looked like. When the sample size increased to 7, this is how the data looked like. When the sample size increased to 10, you can see at each point the deviation is reducing. Can you all see over here? It was completely like flat. I got a standard deviation like this, then I got a standard deviation which has reduced, and then later it got further reduced. Correct? Can you all see it? The deviation is reducing as the sample size is increasing. So all of you just absorb this information for 1 or 2 minutes, right? Try to just see this and kind of read these numbers by yourself. If you still think there is any confusion, please just ask me. So you do not have any, so Rishabh, you do not have any problem statement for that. Correct. So basically, this is a theorem. Now, this is already proven, right? So, I mean, when you say Pythagoras theorem, correct, you can only say that, you have, if you will give me a right triangle, this will always be proved, correct? And theorems are something that are proved, correct? We do not have a lot of the problem statements for that. But yes, those theorems are used for solving some sort of business problems that definitely we will be taking a look at. But for now, what we will be doing is, you know, we will be just see that stuff, how we will, prove this thing with the help of R over here. Okay, let us do this stuff over here now. So what I'll do is over here, I'd like to show you some stuff over here. So how do we calculate the mean value? Do we all know this? How do we calculate the mean value? In the R, if I have a data and I want to calculate the mean value, how will I do that? Swati, you are having a doubt. Sorry, I just saw this. If we are taking sample size 80, that means it will be a curve of mean values of 80 sample. No. So Swati, there are two things. One is sample. Okay. So one is sample and another term is sample size. Okay. There are two things that we have. Okay. So just to make you clear on this, Swati, like for example, what happened is you say that you ordered, so some chips company came to your home and they say we sell very delicious packet of we sell some great chips. So you should buy the chips from us. Now you will say, okay, no, I don't trust you because you are a new brand. Send me a sample of that. Okay. You ask them, send me one sample. And now when they will send you one sample, in that one sample they can share, they can send you 5 packets of chips. Do you agree? So if I'm sending you one sample, I'm saying मुझे एक sample भेज दो, उस sample में मैंने आपके पास 5 पैकेट भेज दिए. Correct? This is what we mean by sample. और जो उसमें 5 पैकेट आए, हम उसको बोल रहे हैं sample size. ठीक है? सो नाउ देन आई सेड कि बॉस, आपने मुझे एक सैंपल भेजा है, मुझे उस पर भरोसा नहीं है, आप मुझे 10 सैंपल भेजो. तो उस केस में वो क्या करेंगे, आपको 10 सैंपल भेजेंगे, तो हर सैंपल में कितने पैकेट होंगे, हर सैंपल में सॉरी कितने पैकेट होंगे उसमें 5, राइट. तो 10 सैंपल आपने मांगे और हर सैंपल में मेरे पास 5 पैकेट थे उसके. सो दैट इज व्हाट दैट सैंपल साइज इज. सो दिस इज द सेम थिंग. तो हम क्या कह रहे हैं इस केस में कि अगर आप अपना सैंपल साइज बढ़ा दोगे, जो आपने 10 सैंपल मुझे भेजे थे उसमें अगर आपने 10 सैंपल जो आपने मंगवाए, हर सैंपल में 5 पैकेट हैं, तो जो उसका स्टैंडर्ड डेविएशन है वो थोड़ा ज्यादा आएगा. लेकिन अगर उसका साइज आपने बढ़ा दिया, इस बार कंपनी ने आपको हर सैंपल में 5 पैकेट की जगह पे 10 पैकेट भेजे, तो अगर आपका सैंपल साइज बढ़ गया तो उससे आपका स्टैंडर्ड डेविएशन और कम हो जाएगा. ओके, नाउ इज इट मेकिंग सेंस? So now what we will do is we will actually try to do this thing in the R and we will try to see that result over here. Now what you will do is, first of all, we will be creating the these some numbers over here which will be uniform distribution. अगर आपको randomly, if you have to create some random uniform numbers, so we have a function for that, that is RUnif. Okay, we have a function that is RUnif. See, because it is not possible for us to write 10,000 numbers or 5,000 numbers by hand, so there are some functions that there are certain functions that we have in the R which can generate the uniform numbers for us very quickly. So if I say RUnif, I want to generate 10 numbers, it will generate 10 uniform numbers for me. Okay, it has generated the 10 uniform numbers for me. So what are uniform numbers? Uniform numbers are basically the count of each number will be same. The count of all the numbers will be same. That is something that is called as uniform, right? We used to have that school uniform. What does that school uniform meant? School uniform meant was that all the students in the school, they should look like the same, right? That is why we call it as a uniform that we wear, so that all the people look same. So same is the concept with the data as well. Uniform data means each number will be coming the same number of time. So if you will try to see that, what you can do is you can create a histogram on that. So if I create a histogram, because that is the best chart to see that thing, whether the data is all the numbers are of same coming equivalent number of times or not. So let us create a histogram on that. say suppose of 100 numbers. Let us see how the chart looks like, right? Can you see it? The chart looks like it goes like a straight line. I mean, definitely it will not be exactly the straight line you will get, but more or less you can see that, you know, this is how the chart looks like with the uniform numbers over here. All the numbers you see, they are somewhat similar to each other. The more numbers you will add to this, better that uniform the chart will become over there. So if you now run this, now you see this chart looks little more uniform. As I'm increasing the numbers in this chart, I can see the things to be increasing over here. The chart is looking uniform to me. Is it making sense to all of you? See, now 10,000 numbers. Now this is how the chart is looking. Uniform means all the numbers are coming in the somewhere similar to that the numbers over there. The count is similar. Similarly, we have a function that is called as R norm. Okay, there is a function that is R norm. Now, R norm is something that will generate the random numbers which will be normally distributed. Say, suppose I generate 10,000 numbers. Okay, these are 10,000 numbers that I have printed. Let me put this into a histogram. Let me put this into a histogram. You see, all these 10,000 numbers that are generated, they are coming in the normal distributed curve. Do you all agree to this? What this chart is showing me, how this is looking? So I am randomly generating because it is beyond my capacity to write the 10,000 numbers by myself. So I am taking the help of R to generate those numbers for me. The class, you know, I can see a lot of silence. Is it not clear? Doubts? I don't see any yes or no over here. See, basically, you know, there are two things. One is called as uniform and one is called as normal. What is normal distribution? What is normal distribution? First of all of you tell me. So, Sahil, you tell me what is normal distribution? So, what is normal distribution?
Normal distribution that we have been talking about till now, it's that the data is evenly distributed and we'll get a bell curve chart.
Correct, right? So, normal distribution data is in which, if say, suppose I have a class of 100 students, okay, all the students, right? All the students will be equally distributed on the lower side and on the higher side, correct? This is what we mean.
Yeah, yeah.
Okay, so when I say, you know, if the people between the age of 10 to 15, if they are, say, suppose this much, so over here between 25 to 30 also, we will have similar amount of a people who actually complement that. Now, this is called as normal distribution. Now, normal distribution means that for all the different age groups, we have the same number of student. So if I'm saying how many students do I have between the age of 20 to 25, you will say, I mean 10 students. Okay, I say, okay, good. How many students do I have between the age of 25 to 30? You will say, I mean 10 students. Oh, nice, right? I get the same bar over here. I say, okay, how many people do we have in the age of 30 to 35? You will again say, I mean 11. It is just a little higher than this, right? This chart curve will like look like that. And I say, okay, how many people do we have between the 35 to 40? You will again say, I mean 10, right? So for all the age groups, we have somewhat similar kind of a count that is called as uniform. Making sense? Uniform and normal distribution.
Okay, so how do we use both these functions differently? As in, what is their purpose exactly?
See, now over here, so you know, before I come on to that function, so I would like to ask other people, are we all clear on what normal distribution is and what uniform distribution is? Okay. See, now you know, like this function R, right? This R over here stands for random. Random. Okay, one way is you create your own data. Okay, I say, okay, you know, create your data where you have to give me a data like this, where at people between 10 to 15 should be 10, 15 to 20, it should be 10, 30 to 20 to 25, again 10, 10, 10. You will have to make the data, which will be a, you know, time taking process. And if I want that sample to be really big, again, it will become much more hectic challenge for you to create that stuff for you. So in order to ease that thing out, R has given you functions that stands for random. Random means R will by its own, it will give you set of numbers that will follow that distribution. ओके मैं आपको क्या कह रहा हूँ कि बॉस आपको डेटा बनाने की जरूरत नहीं है, आप एक फंक्शन चलाओ, आपको वैसा मिलता जुलता डेटा मैं आपको ऑटोमेटिकली जनरेट करके दे दूंगा. दिस इज व्हाट दिस फंक्शन स्टैंड्स फॉर. Right, if you use in the, if the people, if you have a little bit exposure on the Excel, right, I'll show you this. Okay, in the Excel also you have the same function random. Okay, if I say equals to this rand function, what this rand function does is it gives me a random number between 0 to 1. ये मुझे हमेशा 0 to 1 के बीच में एक random number देगा. राइट, तो मुझे नंबर लिखने की जरूरत नहीं पड़ी, मुझे कुछ सोचना नहीं पड़ा, ऑटोमेटिकली मेरे सामने मेरे पास एक नंबर आ गया. अब सपोज करो मुझे एक एक डेटा बनाना होता है जिसमें मुझे सपोज करो से सपोज आई हैव टू क्रिएट अ डेटा वेयर आई वांट टू हैव डेटा ऑफ यू नो से सपोज 100 स्टूडेंट्स, right? I want to have a data of 100 students. I want to have age of all the 100 students over here, and I'm creating dummy data. Okay, don't you think it will be a real tough job if I enter 25, 26, 23, 22, 25? It will be a hectic job for me to make that data, right? Because I am making a dummy data for my just the purpose of learning over here. So what instead I can do is Excel gives me a function. I can say equals to rand between, it will give me random numbers. I say the minimum number should be 20 and the maximum number should be 30. Okay, now I don't need to do anything. I will simply drag it down up to my 100 cell. I'll go over here, and now what will happen is, see, Excel has generated that random data for me. I do not have to enter that number anywhere manually, right? You can see everywhere the numbers are generated. Is it making sense to all of you what we are doing? What this random function has done? So random function is something that generates numbers randomly following that criteria whatever we specify. Now the same thing is being done by the runif, right? So I'm not sure if we have this function in the Excel also. If I say runif, no, so we do not have that function over here. Basically, when I use the function runif, in this case what will happen is my Excel or my R, it will automatically generate the uniform numbers for me. And when I say norm, it will randomly generate normal distributed numbers for me. That's it. Making sense? Now is it clear to all of you? Anyone still having any doubts?
So, just one more thing. So if we are using our norm function, so it means that the numbers generated will be around a specified mean, right?
Uniformly distributed.
So yeah, so for example, if I say कि the mean for the data is, let's say, 5, so under our norm function, the numbers generated will be around 5.
No, uniform data does not have a specific, the mean over here, around the mean. So uniform is what, right? This is
No,
what.
no, not the distribution.
Sorry. Hello.
I'm talking about the R norm function.
So in the R norm, yes, it will be around that.
Hello.
Yeah, it will be around that mean.
Okay, okay.
Yeah, right. So now if you see over here, if I say R norm function over here, right? So it asks us how many numbers do you want, right? I want, say, suppose I say I want 1000 numbers to be normally distributed. Then if you specify the mean also, that you want that the numbers should have a mean of 10 and standard deviation of 2, it will generate the numbers according to that. You see, everywhere you will see, if you will find, so let me save this number, let me save these numbers into a variable, let me call it as R. Okay, let us save it. Let us find the mean of R. Mean of R. 10, right? So I specified the 10 only. That mean should be 10. Correct? I'm getting the 10 only over here. Now if I say standard deviation, let us find the standard deviation of the R. So it is coming as 1.99. That is exactly approximately 2 only. Right? So we are getting that same number over here. Okay, so all of you, is it clear to all? Are we all on the same page? R norm, Nandini, what do you want me to explain over here? R norm. So R norm is a function that I have used. So it will generate the normal distributed numbers for me. Okay, so R norm is a function that will generate the normal distributed numbers for me. So there are certain input parameters that this R norm function can take. So if I simply say, I'm saying R norm. So if I simply say R norm and I put the number over here as 1000. Okay, if I put 1000 over here, now it will randomly generate 1000's number for me. It will generate randomly 1000 numbers for me, and their mean will be 0. The mean of these 1000 numbers will be 0. So this is default, right? So if I now find the mean of this, it will tell me that the mean, so this is default. This is the default that you get. Default R norm mean of 1000 numbers. This will come out as 0 if I run this. Minus 0.02, which is 0 only, correct? So this is the default. But what I'm saying is, the numbers that I want, they should not have a mean of 0. So I'm specifying everything that, I want 1000 numbers which should have a mean of 10, right? And it should have a standard deviation of 2. So I have defined my own mean and standard deviation. Clear now? Perfect. Others, are you all clear on this? Great. Prerit, how about you? Perfect. Now what we will do over here is, so now this sample you have known, right? How we can create a sample, right? I mean, how you can pick up some numbers over here. So what we'll do over here is, in this case, what we'll do over here is, we will be taking, first of all, we will just take one, the normally distributed, the 10,000 numbers. Just pick up 1000, uniform numbers, or 10,000 uniform numbers with you. Just pick that up. Okay, all of you, just follow this step. Create a variable, and in that variable, store 1000 uniform numbers in it. All of you, please do this. Okay, what you need to do is, you just need to create a variable R. In that variable, you all have to store, what do you have to store? You have to store 10,000 uniform numbers in that. Okay, 10,000 uniform number in that. Can you all create it? Simple to go. Just this command and you will get 10,000 numbers which are uniformly distributed. Let us take the mean of this. Let us take the mean value of this, mean of R. What will be the mean of these values? What will be the mean if I'll check the mean of these values? What that mean should come? Yes, class. What should be the mean if I calculate this? Yeah, definitely that will be random, average of random numbers. But what will that be? 0? Shouldn't it be 0? I mean, yeah, it is like uniform numbers. Yeah, so in case of that, it should have been 0. The 0 in the normal distribution, but in the case of our unit, you will get it as 0.5. That too lying in the middle, right? 0.5. Now what we will do over here is, now this is a big sample size that I have taken. Okay, I have taken a population of 10,000, right? I have taken a population of 10,000. Now what I want to do is I want to take a sample from this population. I want to take a sample. How can I take a sample out of this? I have 10,000 numbers. So what will that sample mean? What will that sample, what do I understand by the sample? So suppose I want to take out a sample of four numbers. I want to take out a sample of four numbers. So what does that mean? First of all of you tell me this. When I say I want to pick out a sample of four numbers, what do we understand by that term? Yes, class? So shall I show you the four numbers over here or 10,000 numbers over here? Shall I show you the 10,000 numbers? These are the 10,000 numbers, right? These are the 10,000 numbers that we have stored in the variable. Okay, ये 10,000 नंबर हैं जो हमारे इस R वेरिएबल में stored हैं. You can see all the 10,000 numbers over here. And if I say that I want to pick a sample of four, I can pick any four numbers, right? I can pick one this number, I can pick one this number, and then what I can do is I can pick some other number as well. So randomly I can pick four numbers from here, correct? I can do that. Right. So how can I do that in the R? See, I have understood this thing theoretically, but how will I do this thing with the help of R? So in the R, we have a function that is called as sample. Okay, we have a function that is called as sample. So sample function is very easy to use. If you will simply say sample from the variable R, you want to pick sample of four numbers. Okay, I want to pick up a sample of four numbers. So let us execute and see. So it has picked up these four numbers. So it has randomly picked four numbers from there. If I'll run it again, this time it will pick up another set, a different set of four numbers. If I run it again, see this time it has picked up some other four numbers. If I'll run it again, it will pick up some other four numbers. So every time I'm executing it, it is every time picking up different set of four numbers for me. Why? Because it is a sample. It will always pick up the numbers randomly. Making sense? Yes, class? What this sample function is doing? Everyone clear on the random function? Everyone clear on the sample function? If anyone has any doubts, please ask it right away. Okay. Now,
Just one question.
yes, I.
Yeah, just one question. When we were talking about the R unit function and we plotted a histogram for that, so we saw uh, 10 different
Sorry.
samples in it, right? So does that mean that whenever we create a histogram, it will always be in 10 samples, in 10 samples?
No, so when you are creating this over here, you said hist, right? You did a hist on R, right? This is what you're referring to.
Yeah,
So if you now see this chart
yeah,
over
yeah, yeah.
here, so this is the chart that we have got. So these
Yeah,
are
so we
different
see
bars.
from 0 to 1.
So because randomly it has picked up the number between 0 to 1, because the numbers
Yeah,
fall within the range of 0 to 1. If you would have specified some other range, it would have picked up the numbers within that range also. Okay, like what I
okay.
said was that by default, if I say R unif, okay, so it is randomly picking between 0 to 1. Okay, default, it is default. Now if you will say that you want
Yeah,
10,000 numbers between 100 to 500, so now it will give you 10,000 numbers between this range. So if I'll show you,
yeah.
so if you see now the numbers are between that range, 397, 225, 449. So now if you will create a histogram on that, if you will see the histogram, it will have a different range. See, because my minimum number was 100, maximum was 500. So 100 to 120, 120 to 140, 140 to 160, 160 to 180. So this is how the numbers are generated.
Okay, okay. And we are saying through this so through this is histogram we can interpret that in each sample has almost.
See, over here we haven't taken a sample. We are not talking of sample over here. What is a histogram? First of all, tell me, Sahil, what is a histogram?
Histogram is basically a chart in which
Hmm.
how do I explain this? Basically, we are looking at the frequency of a particular thing occurring in it.
And what frequency are we looking at?
The number between, for example, two limits,
I mean,
the
you're
minimum
just
and the maximum.
so you're just halfway clear onto this, right? You don't have the complete. So let me just make it you understand. How many numbers have I printed?
10,000.
10,000. Correct. What was the range that I selected?
100 to 500.
100 to 500. This is the minimum number and this is the 500, the maximum number. Now, if I say number 120, okay, if I say 120, if I ask you, so
Yeah,
will that number 120 be coming just once in this range, or there is a chance that it can come more than once also?
it can come more than once.
It can come more than once, right? क्योंकि हमारी नंबर की जो रेंज है वो 100 से लेके 500 के बीच में है, right? Only 400 numbers की हमारे पास रेंज
Yeah,
है, and the numbers that we are taking total are they are 10,000, right? So there is a 100% chance that 120 can come more than once because the range is very less and the number that we want they are very big. Correct? Now what I'm
hmm,
doing is between 100 to 500, what I'm saying is I am saying tell me how many numbers do I have between 100 to 120? How many numbers do I have between 120 to 140? How many numbers do I have between 140 to 160? Right? And then I'm saying how many numbers do I have between 160 to 180? Okay, this way we are
yeah,
going up till 480 to 500.
500.
Correct?
Yeah,
Correct. So uniform distribution tell me that the numbers that I will be, the count of numbers, the frequency of numbers that I will be having between 100 to 120, say suppose that is 300. So there were 300 numbers in my data that were in this range. Okay.
okay,
Then I'm saying
okay,
there were 310 numbers that were between this range. Then similarly, I am saying I had 305 numbers between this range. Correct?
yeah, yeah.
This is what we have plotted on the histogram. So between 100 to 120, what count do I have? Between 120 to 140, what count do I have? So this is the same thing that is coming onto the chart as well. 100 to 120, 120 to 140, 140 to 160, 180 to 160 to 180, 180 to 200. So this is the same bar. So we are having approximately 500 numbers in each bar over here. Can you see it? Frequency over here. This is nearly to 500. So the number that I have assumed to be around 300,
This has
that
nothing to do.
it has nothing to do with sample. So we have not taken a sample up till here. Nowhere we have talked about a sample.
Yeah,
Sampling is the step that is happening after this. So these numbers that you have generated, these numbers that we have generated, now I am
okay, okay,
asking you, yeah, so now I'm asking you pick up a sample of 4 numbers from there. Yes, so is it clear to all class?
okay, okay, okay. Understood, understood. Okay.
Right. So now what we are doing is we are picking up a sample of 4 numbers from there. So if you will pick up a sample of 4 numbers from there, so this is the 4 numbers it will pick up and show you over here. These are the 4 numbers. So every time you will pick up a sample, it will always be a different, right? It is like, there are 10,000 numbers in a basket. Every time you are putting your hand, you are getting 4 different numbers. So this is the same thing that is happening over here. Class, are we all sorted up till here? Diksha, Sushma, Ranati, Rishabh. Perfect. See, now here comes the twist. Okay, now I would like to see how many of you are actually practicing the stuff. How many you got their hands dirty on it. Okay, now you will have to relate back to that central limit theorem as well. Okay, the central limit theorem was that if you have a uniformly distributed numbers with you, a big population with you, if you will take out lot of samples from there, right? If you will take out lot of samples from there and find their mean, those mean numbers will be uniformly distributed. Okay, those numbers will be uniformly distributed. Am I right? Guys, am I right? Correct. Now, how many sample have I taken up till here? How many sample have I taken over here? This is just one sample? No, this is one sample. Sample size is 4, right? सैंपल का साइज 4 है. उस सैंपल में मैंने 4 नंबर लिए हैं, पर सैंपल तो एक ही है ना. अभी तो ये मैंने एक सैंपल निकाला ना यहाँ पे. दिस इज वन सैंपल विद 4 वैल्यूज इन इट. करेक्ट. Now I say I want 1000 such samples. I want 1000 such samples. How will you give me 1000 samples over here? Okay, I want all of you to give me 1000 samples from here. I have 10,000 numbers. I want you all to generate 1000 samples for me, and each sample should be of size 4. Yes, I would like to see who can think it, right? Even if you're not able to, if you can give the correct answer, that is the best thing that you can do. Even if you can give me the logic also, that is much more appreciated. I will be able to understand that you guys are actually practicing the stuff. Huh? So you are saying sample R 1000. So this is like, this is a disaster that you have given. That means you have not understood this sample function itself in itself. Right? If I am saying sample of R putting 1000, what is 1000 over here? 1000 is the sample size, right? That you are picking one sample over here which will have 1000 numbers in it. But what is my question? First of all, comprehend the question. My question is, मुझे चार के सैंपल का with the samples with sample size of 4, I want 1000 samples. This is what I want. So I think, yeah, Subhakaran, you are going into the right direction. We all need a loop over here. Perfect, right? So I just got one correct answer from, the population of 40 over here. And there is only one person who is correct. Raghu, just try this out, right? The thing that you have written over here, you are saying you take a sample, okay? So this is simple board mass that you have done, right? This is just a simple board mass that you have to apply over here. You are saying sample from R, and you pick a sample of 4 numbers and multiply it by 1000, right? This is what you are saying me over here. Please try this out at your end and tell me what are you getting over here. So
No, Amit, what I tried to say is 1,000 times. For example, if we put A is equal to sample R comma 4, similarly we need to create a variable for 1,000 times. So we will have a 1,000 number of samples.
Yes. So we need to bring that 1000 times. Correct.
Yeah.
Perfect. So, we will need a loop over here, right? Like, Subhakaran mentioned, Bhuvneshwari, you have mentioned So there are two kind of loops that we have, right? One is while loop and another is for loop that we have, correct? So either of the loops you can use in order to generate those numbers, right? Maybe, I will go with the for loop. So if I say for, right, let me just type this again, I in 1 to 1000, right? So how many times will this loop work? If I write this code for I in 1 to 1000, how many number of times will this loop work? 1000 times, right? So this is something that has to be done with the help of a loop over here. So now do the next part of this. Can anyone explain me the logic? If anyone can, just take the lead and come and take the mic and try to explain what that logic will be. So that will be really great.
Hello.
Yep.
If we keep using the like if we use the for loop, it will keep repeating itself unless we break it, and we can have as many times as we want. Like if we want the sample 1,000 times, it will keep on repeating until we have reached like the limit of 1,000.
Okay. See.
Sahil here. So when we are doing loop, so
Okay. See, let us try this out, right? So what I will do over here is I am saying for I in 1000. So first of all, what do I need to say? Do I
so
actually,
when we are what sample result, I've just pasted. I'm asking is that I need
sorry, is it silence? Your voice is breaking. I'm not sure. I can see the chat, what you have shared. Right, right. So, something that you have shared over here, that is absolutely right. So let me come up to your point. So, what I will do is, if I say for I in 1 to 1000, and you say print, okay, print, what do I want to print? I want to print a sample from R of 4 numbers. This is what I want to print, correct? But will this serve my purpose? No. Because what will happen in this case is this loop will work 1000 times and it will keep on giving me 1000 samples over here, but I will not be able to store them. I will not be able to store those numbers. Right? That is what the challenge is. So, right, this is where Raghu has given the answer. It will assign 1 to n. No, I think no. I think someone said about a variable. Basically, what you actually see over here is right side. So we need to have a variable, and also in the variable I don't want to store the complete sample. Do you really think that I am interested in the complete sample over here? Class, do you think that I am interested in the complete sample? What is the final number that I am interested in? Am I interested in the sample, or I am interested in the mean of the sample? What is my final thing? Mean of the sample, right? Just speak in your mind, right? I want the sample mean, right? How can I find the mean of this sample? How can I find the mean of this sample? I can simply say mean. I want to see the mean of sample of, from the R, pick up the number of 4. It gives me a mean over here. Every time I will run this function, it will give me a different mean, right? Every time I'll run this function, because every time it is picking 4 different numbers, and that is why the mean is changing. Correct? The mean is changing because every time what is happening is I'm picking 4 different numbers. The mean is changing every time. See, I have calculated 1, 2, 3, 4. I have calculated the mean 4 times, and all the 4 times I have got the different mean over here. Correct? So can I change my formula over here? Instead of saying sample of R, can I say mean of sample of R? Can I say this? Can I say this? Yes, class? Correct? Right. I hope you all are understanding it, right? Please do not move ahead if you have slightest of the doubt over here as well. If you think, there is something that is still not making sense, that what Amit has written over here, or how, see, all the things are coming from the previous classes where we studied the for loop. The same thing has come up over here, nothing new. It is just the concept that we are applying, and concepts are something that will change with every problem statement, with every data and every question. So concepts are something that we all will have to build slowly and gradually. Every time you will get a new data or something new challenge, you might have to use the for loop, but the logic will be different. So logic is something that you will all have to start thinking upon. Okay. Now what I do over here is, like, as you all mentioned, and Nandini, so the sample the question was to, we are going by that center limit theorem, right? This is something that we are trying to prove. So we want to generate the mean value of the sample that we are picking. Even if you pick the sample also, everything will remain the same. There is nothing that will change in the code. Still the things will remain the same. Now what I can do over here is, because I do not have to print the numbers, I actually have to store the numbers in one of my variable. So how many numbers will I have? How many numbers will I have after the for loop will be completed? How many numbers will I have? 4,000, 1,000. We will have 1,000 numbers with us, right? Because we are calculating the mean. आपने 4 का सैंपल लिया, उसका मीन निकाल दिया सीधा, तो आपके पास तो एक ही नंबर बचा ना, उस 4 के सैंपल में एक ही नंबर बचा जो था मीन। तो अगर आप उसके 1000 सैंपल लोगे तो आपके पास 1000 नंबर आएंगे, करेक्ट? सो वी आर लेफ्ट विद 1000 numbers. ठीक है। Now how can I store the 1000 numbers? Where, in what format can I store those 1000 numbers? Vector, correct, right? So you can store those 1000 numbers in the form of a vector, right? So what I can do is, so everything is done, right? You all have given the answers by yourself. What I need to do, what I'll do is I'll create a variable that is CL, right? I'll call it as CL4, because I have made the same, I am calculating this thing for a sample size of 4. So I am saying in the CL4, I want to store this mean number. I have stored one mean number in one of my variable. I have stored that number mean over here in my variable. मैंने एक मीन नंबर स्टोर कर लिया। अगर आप चेक करोगे यहाँ पे CL4 में एक मीन नंबर मैंने स्टोर कर लिया यहाँ पे. So I have stored one number over here, 0.6. But now I have to just update this CL4. I have to update this CL4 so that it stores all my 1000 numbers. So what will the code? What will be the code? I will say CL4. It should be updated. CL4 and the mean of. Just copy this part just to save the time. I'll simply copy this, and there we are. So my code is done. That's it. Just one liner code, nothing more than that. Now what will happen is, when the loop will run first time, I will be 1, right? And then in that case, what will happen is, it will calculate the value of mean at that point in time. It will update in this variable. So it will become CL4, the value that was there previously, plus the new value. Now it will have two values. When the I will become 2, again one more mean will be calculated. By that time, CL4 already had two values. In that, we will add one more value to it. Right, Bhuvneshwari. So after the for loop completes, we will be having a total of 1001 values, because one value was already there while creating that variable, and inside then we are running that loop 1000 times more. So we end up getting 1001 values in it. That's it. Let us calculate. Let us do this. Let us create this. Everything is done. My loop is created. If you will check the CL4, now if you want to count the numbers in that, you have a function of length, right? You can say length of CL4. So how many numbers will I have in it? 1001. I have 1001 numbers in it. Now what I'll do on this is, let us create a histogram on this. List of CL4. See, the numbers have come in the normal distributed format, right? This proves my central limit theorem. That's it. Yes, class. Any questions, any doubts over here? Okay, so over here with this, no, I think a lot of stuff has been done. We all, oops, my battery is also going to just give me a minute. Now with this, what we all will be doing is we'll take a quick 15 minutes of a break over here. And after the break, you all will do the same thing. You will do the same thing and you will create a similar kind of a vector now with a sample size of 9. Okay. So let us just connect after the break. So we'll connect at 10:15, sorry, 10:30. Okay. So we all have a break time till that. Hello. So, hi class. Shall we start? I hope all of you are back. Perfect. Okay. Dev, Prerna, Prerit, Nandini, you all are here. Others, can I have just to see all of you are over here? Great. Now let us start with this procedure over here. So, anyone having any doubts on this part of the code that we have written over here? Anyone who is still not clear on this?
Amit, Raghu here.
Hello, yeah, Raghu.
So I have one doubt in this for loop. So there is no need to bring that I within this parenthesis. Sorry, just flower brackets.
No,
So within the loop, simply within the loop, no need to mention that I value.
no. See, because what is happening is I
Okay.
is automatically incremented. When the first time when the loop will run, it will become one. Next time it will automatically become two. Next time three. Right? If in case you think that there is a requirement, where you think that some number inside the loop has to be incremented, like in case we were printing the table of five. So over there you can simply say five into I. So first time it will be one, second time it will be two, so it will automatically keep on getting
Oh,
multiplied.
oh,
Right?
okay.
Thanks, Raghu. So
Got it.
now, class, all of we have created a vector which is CL4, which has 1001 numbers in it. Okay. Now, all of you create similar thing, call that variable as CL9. Now, in this case, what you have to do is you have to create a vector of 1000 samples, but over there, the sample size should be of 9. The sample size has to be of 9. Clear that? So Swati, the problem that has happened in your case is you have not executed this command where we first defined that variable CL4 in which we saved that mean value. So you didn't use this command and straight away you actually executed this loop. So CL4 was not created by that time. Will all of you please create that CL9? So Nandini, we want a sample size of 9 in that case. So I want you to create a vector with 1000 means of the sample size 9. Previously we were publishing the sample of 4. Now this time I want a sample of 9. Correct. Correct, Rishabh. So you have created correct. Okay. So for all the people who still had any doubt, so for them I'll just repeat it. So now if I say sample of, I pick up a sample from R and I pick a sample of size 9. So Swati, how many values will it give me? How many values will it give me? In sample, how many values will I have? 9, correct? So we'll have 9 values in this. If I'll run this, so now this gives me 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. Now, if I find the mean of this, so what I will do is I will put a mean on this, that I want to find the mean of these 9 numbers. I get a mean of this, that is 0.7. Now what I will do is I will save this number in my variable, that is CL9. So I will be saving this number over here in the CL9 variable, and I will execute it. So that one sample that I had saved that number into my variable. Now what I want to do is I want to save similarly 1000 numbers in it. So I will say for I in 1 to 1000, what do I want? I want to update my CL9 with, so that will be C of CL9, the mean of this number. That's it. And I'll run this and get a sample of these numbers over here. Right, class? So, Prerit, I think, do you all hear some breakage in my voice? Hello, class. Can you all hear me? Okay. See, it could be due to that network challenges that would have happened. It just would have been due to that. Is it fine now? Is my voice coming clear to all of you now? Okay, perfect. So now all of you do the same thing. Now do one more thing over here. Now you all have to create again a vector which should be CL16. I hope all of you can understand now what is CL16. I want 1000 numbers in this vector CL16 with a sample size of 16. Now do the same thing. I want now 1000 mean values on a sample size of 16. This class, please create a vector with 1000 numbers in it with a sample size of 16. Correct, right? Rishabh, you have shared it correct. So everything is same. You just have to copy and paste the above scenario. That's it. Only thing that you have to change in this is everywhere it is 9, I will change it with the 16. That is it. Here I have 16 and here also I will have 16. And here also I will have 16. And here also I will have 16. That's it. Oops, I just didn't this CL16. Right? So now what I have created a lot of stuff. We have CL4, we have CL9, we have CL16. And one what we have is we have R. right? These are the four numbers that we all. Okay, class, can you hear me now? I think there was some network challenge that happened. Can you hear me? Hello? Hello? हाँ मैं एक्चुअली पहले चेक कर लूँ वो आवाज जा रही है नहीं जा रही यहाँ पे आ जाता है ये क्लास वे दोनों हाँ वे दोनों लैपटॉप सेशन चले गए हेलो क्लास कैन यू हियर मी हाउ आर यू गोस okay sorry class I think there was some network trouble that we had so see what I was trying to show you over here was that we have created four variables now, right? One is R, one is CL4, one is CL9 and one is CL16. Are we all sorted on this? Are we all clear like what these are, what these four things are? Okay, so what is R over here? What is R? Yes, Jyoti, what is R?
R is the R is the variable in which we have defined it as the R unit 10,000.
Right, so that is the population, right? So R has the
Yeah.
population, rightly said by Sakshi and so basically it is the population which has 10,000 numbers in it. What was R14? What was R14? Oh, sorry, CL4. Sorry. CL4. What was CL4? It was a sample, correct? How many samples did we had? How many samples did we had? No, so that was sample size. 4 was sample size. We had 1,000 samples with the size of 4, right? With a sample size of 4, correct. And what we did in this was we also stored their mean values, right? We stored the mean values in that, correct? We picked up the first sample, we calculated their mean. We picked up the second sample, we calculated their mean. We picked up the third sample, we calculated their mean, correct? Are we all clear on this? Now same was the concept with CL9. So again we had sample of 1,000, we had 1,000 samples. Now over here the size was of 9. This was the sample size. Now what was the mean value? We stored mean values of that. Correct? Are we all sorted up till here? Now I would like all of you to calculate All of you just give me what is the standard deviation of population. What is the standard deviation of population? See, all of us can have a little bit of a different standard deviation because we all had different random numbers in our data. So we all will have a different standard deviation. So I would like to see who gives me the number over here. What is the standard deviation of population? Okay, Disha 0.287, right? So Sahil 0.28, correct. So let me also check it out. It will be SD of R, simple, 0.28818, correct. This is also the same number, similar number that I have also got, like the what you have got. Now you don't have to use, no one of you will be using R over here now. Okay, you have got the standard deviation of the population as 0.288. Now my question to you all is, according to central limit theorem, what should be the standard deviation of the mean values where we had a sample size of 4? Without using R, you have to give me that number. What is the standard deviation of the CL4? You do not have to use R, please. No one will use it. You all have to give me the standard deviation of CL4. Yes. So Raghu says 0.143, Prerna says 0.14. So how have you got this number? Surya, how did you got this number 0.145, or Vishal, how did you got this number 0.145? So Raghu, I clearly mentioned over here, right? You do not have to use the R over here. So you didn't have to use the formula of standard deviation, right? So that is any which way is very straightforward, right? So I would have not asked that part. I said that you do not have to use R in this case. So we are using the central limit formula, right? So what we will be doing over here is we will go by the learnings that we had just in the previous session over here. Okay, so how is the standard deviation changes? So this is what the formula for standard deviation is. The standard deviation of that sample would be sigma divided by root n. Right? Sigma is what? The standard deviation of the population, right? That is coming as 0.28. Root n. What is n? N is the sample size. Sample size was 4. What is the root 4? That is 2. So if I'll divide 0.28 by 2, I will get 0.14. Am I correct? Yes, Raghu? Vishal? Am I correct? So hence we can prove our the central limit theorem that okay, yes, if my population was, if my population standard deviation was 0.28, if my sample size is of 4, so I'll divide it by 2, so that will give me 0.14. Now what I'll do is I will check the same thing in my R as well, right? So we have manually calculated that number that is coming as 0.14. Now if I'll check the standard deviation of CL4, let us see what the number do I get. I get a number nearby to that, 0.146. So can I say that central limit theorem is doing the things as it said? Okay. Now, all of you tell me without using the formula of, the standard deviation in the R. Now calculate what should be the standard deviation of this. What should be the standard deviation of this? That should be 0.28 divided by 3, correct? 0.28 divided by 3, so 0.28 divided by 3. So if I see this, I get 0.09333. So let us check, are we getting the same result over here? CL4, oh sorry, CL9. Yes, we are very near to that, right? Almost the same number, right guys? Class? So now I would like to ask a question. So I will like to ask this question over here to Ayush. Ayush, can you hear me? Okay, great. So Ayush, what has happened, right? Can you tell me, like, when I have increased my sample size, how has my standard deviation changed? When I increased my sample size, how has my standard deviation changed? Reduced, right? So Ayush, what you tell over here is that is it has reduced. How can you say that? How can you tell that part? How has it reduced? Because what I can see is I can see the numbers clearly onto my screen. The standard deviation of the entire population was 0.28. When I took a sample of 4, my standard deviation came out to be 0.14. When I further increased the sample size, it came out to be 0.093. As I am increasing my sample size, my standard deviation is decreasing. Now similarly, if I'll see the standard deviation of CL16, it will go further down, right? So if I check this out, now it has become 0.07, right? So I can see from here that as my sample size is increasing, my standard deviation is decreasing, correct? Now, and this was the same thing that we had seen in the chart as well, that as you will keep on increasing the sample size, what will happen is the deviation will keep on getting reduced. This was the standard deviation of the population, this was the standard deviation of the sample. Then if I'll take a bigger sample, the standard deviation will further decrease, correct? Is this clear to all? Yes, Vishal. So your answer is perfectly right that, as we can see, the standard deviation is inversely proportional to the sample size. Okay. Now, my next thing is, now we have seen this thing in the form of the numbers. Can I see this thing in the form of a visualization as well? Right? Like, I've shown you over here as the form of a curve. Can I see the same thing in the form of the visuals? Yes, we can do it. Let us create a histogram. If I'll create a histogram on R, right? This is how the histogram looks like. If I create a histogram on CL4, so let me just keep all these things together. So if I create a histogram on CL4, it looks like this. If I create a histogram on CL9, it got further reduced, right? If I create this histogram on CL16, it will get further reduced, right? You can see it. The curve is, which is very scattered, it is getting smaller and smaller, right guys? Can you see this in the form of a chart now? So everything is now clear what we have studied in that central limit theorem. Anyone still having any doubts into this area? Huh. वहाँ पे ना नेट का प्रॉब्लम आ रहा था थोड़ा सा, वाईफाई का प्रॉब्लम आ रहा था उस रूम में ना। Okay, so all are clear over here. Now you know what I will do is I would like to see right now what is happening is these 4 charts are coming in the 4 different views. What I will do is let us create these 4 charts in one single screen itself so that I can see all the 4 charts into one single screen. So how can I do that, right? So if I want to showcase all the 4 charts in one single screen, right? So over there, what we have to do is we have to use the function that is partition. Okay, what we do is with the help of the partition function, we can very easily break this window into multiple parts. Okay, now I'll explain you that what do we understand by that. So I will say partition. See, what is partitioning, right? When we say I want to divide something into 2 parts, 4 parts, 6 parts, that is called as partitioning. So I will say partition. So this is a function that we have, partition. Simply run par, okay, partition. Then you will define, please all of you first of all understand this function and then you can write onto your screens over here. I will say mf row, okay, there is a function for that, partition mf row equals to, mf row stands for multi-frame row. Okay, now what you can do is you can actually break this chart into the different parts, right? Like for example, this is the chart. What I can do in this case is I have multiple ways. I can either break this screen like this. One chart comes over here, another chart comes over here, and another third chart comes over here. Okay, so what I'm doing over here is I am putting one chart over here, second chart over here, and third chart over here, right? That is something that we understand when I'm saying I want to showcase multiple charts over here. Now in this case, if you see the chart is coming row wise, one chart in first row, second chart in second row, third chart in third row, correct? Are we all clear on this? The row wise, how the charts are being showcased row wise? Is class? Correct. Now, what I can do over here is, if I just erase these drawings, I can also show this chart like this. 1, 2, right? So one chart comes over here, one chart comes over here, and one charts come over here. Correct? So how many rows do I have in this? My row is 1, but now I have 3 columns. 1, 2, and 3. Correct? Now I have 1 row and 3 columns. Making sense to all of you? Now similarly, I can also break the chart in the form of like this, right? I can break my charts like this as well, where I can say this and this. One chart comes over here, second chart comes over here, third chart comes over here, fourth chart comes over here. Correct? So this is how also I can showcase the 4 charts. See, there is a reason behind this. I am explaining you all this because this is, you will have to define that how do you want to break your partition. So in this case, how many rows do I have? How many rows do I have in this case? Correct, right? So I have 2 rows. And how many columns do I have? So 2 rows, 2 columns. Correct? So all of you are making sense of this. Now this is the same thing that you will have to write over here. Partition, multi-frame rows, how many rows and columns do you want? So if you define, so first comes your row. If you say 1, comma 2, that means you want 1 row and 2 columns. Okay. Now please understand this part. If I am saying 1 row, 2 column, first is row, second is column. So I will have 1 row. How will the visual look like this over here? How will the things look like? So I have 1 row, 2 columns. So the things will look like this, right? One chart over here, one chart over here. Am I correct? 1 row, 2 columns. Correct. Now, if I say 2 comma 2, it will become 2 rows, 2 columns. So that means over here the chart will be broken into 4 parts. So in that case, I will be able to see 4 charts onto my one single screen. So now this is the same thing that we will do over here. Now I will, first of all, what I will do is I will run my command partition mf row 2 comma 2. And before you run this command, you also have to make sure that you increase the space, because if the space will not be, if the space will be less, the charts will not come up. Okay, so it's always a good idea to first increase the space over here. Okay, and then run your command partitioning like this. Now R has taken the command that the charts will be divided into 4 partitions. So let me just copy those commands, the histograms. What I will do is I will make those charts again over here. First I make this chart, I get the first chart. Then I execute my second chart, I get the second chart. Then I execute my third command, I get the third chart. I execute my fourth command, I get the fourth chart. Right? So now I can see all the 4 charts into one single screen. Clear to all? Perfect. So Yash, you are clear on this? Others? Great, great. Sakshi, you are clear. Sarup, Vishal, Naveen, Sahil, Prerit, okay, Prerit, you're also clear. Great. Now what I'll do over here is, now I can see. Now what happen is, once you run this command, okay, once you run this command, what will happen in this case now is, now R will assume that every time the new chart that you create, it has to come in this 4 window. So now what will happen is, if suppose this, if you just, what you do is, if you create another chart over here, for example, I create another new chart, hist, I create another chart over here. Let me create hist R. See, again, by default, all the charts will now coming in that 4 view. So every new chart that you will create, it will assume that the screen is broken up into four parts over here. Okay, so in case now, if you want, once your analysis is done and you now think that, you do not want the screen to be split up into 4 parts, you want that the same chart should come into that complete entire screen. You will just have to run that command one more time, where you will say partition mf row equal to C1 comma 1. Okay, you will have to run this command, one row, one column, that means one chart. So if you will now run this command, next time you will create the chart, it will come in the entire screen. Okay, so please do not get worried that, like, why is it not coming in back in that same shape, because you would have not executed this command in that scenario. Are we all clear on this class? So Rishabh, I'm not sure, like, it should work every time. I mean, this is a standard function that we have. So in case if you have written the wrong syntax or something like that, so in that case it will not work. And the important thing is, you have to make sure that the space is properly given over here. If the space is not proper, in that case also it will not give you the charts. Okay. Now, with this, we are clear on the central limit theorem, right? So are we all now clear on what CLT is, what normal distribution is, what z-score is, what standard deviation is, right? What standard error is? Are we all clear on these terms? Great, great. So now what we will be doing. So standard error is something, the same thing, Nandini, that the standard deviation that we all calculated, sigma divided by root n, the numbers that we were calculating. Sigma divided by root n, that was what, that's with the other name for that is standard error. Sigma divided by root n. So that is called as standard error as well. Okay, so now now we will be doing a very interesting topic over here. Okay, and the topic is hypothesis testing. Okay, we will be doing hypothesis testing over here. Now this is a very interesting topic, and you should all enjoy this session over here. Now let me ask you a question. What do we mean by hypothesis? What is the English meaning of hypothesis? Assumption. Correct. So Sahil, you are correct in your understanding. Presumption. Okay. Sakshi. So yes, right. So it is something like what we believe. Correct. Can I say that? So hypothesis is something that what we believe, what our understanding about something is. Right. That is something that is called as hypothesis. So let me just open the slides over here. And if anyone was still had any doubts on probability and all, they will all be cleared again, because this is something again, we will be somewhere, coming up to back to that Z scores only in order to understand it in a correct way. Okay. So I'll just open the slides. Okay. I hope you can all see my screen now. So what is hypothesis? Hypothesis means that is used to is something that we use to basically I'm just jumping on towards uh, the term hypothesis testing. Before that, I would like to understand what hypothesis is. Right now, let us take an example. Okay, like in the very starting of the session, I explained you all something, that there are two kind of tasks that we do in the statistics. One is we do not know something about the population. We are taking a sample, and whatever result we get on that, we try to say that the same applies on the population. Correct? And the second thing that we discussed was that I know something about the population, but I want to validate it again by taking a sample. Correct? Yes, class? The two starting points, are we all sorted on that? Okay. So now, the hypothesis is something like if I say that, like the same Maggie example, because we will be discussing that Maggie example a lot in these slides again. So if I say that, this hypothesis is, my assumption is that the Maggie is having lead less than 2.5 parts per million. This is my assumption. Correct? This is my assumption that I have taken, that okay, this Maggie, whatever Maggie packets are manufactured, they have the lead less than 2.25 ppm. Now one company comes to me and then they say that that I'm saying that lead is less than less than equal to 2.5 ppm. In fact, I'll show you that slide only over there it's neatly written. Now a competitor brand comes to FSSI, right? Like this is the Authority of India. They come to the Food Authority of India and they say, Maggie is not the Maggie that is being manufactured, it has higher lead in it. Okay, they come to the FDA and they say, Maggie is not producing the products as per your guidelines. Now what will happen over there is, now FDI team will go to the Maggie manufacturing unit and they will try to validate that thing. Correct? They will try to validate that thing. Now, what will be their hypothesis? What will be their assumption? When this FDI company goes to the Maggie factory, what will be their assumption? With what assumption will they go over there? Yes, class? Okay. See, if they will go with that assumption, that means they have already believed that the lead is higher than that? Don't you think? If they will go with that mindset, that they have led more than 2.5 million, so that means they have already believed something, that it is more than 2.5. Correct? Am I correct in saying that? Okay. Now when I say, let's take one more example over here. Okay. Now let's take any more example. Now this is more generic example over here. When there is a culprit that is held for some crime. Okay, suppose there is a criminal who has been held for some doing some kidnapping or some murder and all. Let us assume that there is a culprit that has been held. Now he is taken to the court. Now when he is standing in that court, how does judge looks at him? How does judge looks at that culprit? Does he looks with the eyes that he is a culprit, or does he looks with the eyes that he is an innocent? Innocent, right? Why so? Because as a general assumption, we all feel that everyone is innocent, right? Till the time you cannot give any strong proof that yes, he is the culprit. Till the time, if suppose the lawyer is not able to give a strong evidence that he has done the murder, he will not be treated as a guilty till that point in time. The moment he gives a proof that yes, this is the knife which he used and it has the fingerprints of that culprit. Now the moment you have that proof with you, then you can say that no, that yes, he is guilty. I was wrong in my assumption. I was wrong in my assumption that he is not, he is innocent. I am wrong in my assumption. Correct? Are you all able to get my point? Now the same thing will be applied to that Maggie testing as well, right? They will go that no, we trust him that yes, because we have set it up a guidelines that the Maggie should be less, the content should be less than 2.5 parts per million. Now they will go with that assumption that Maggie is following that protocol. Till the time they will not get some evidence that yes, in the Maggie the lead was more than 2.5, they cannot take any action against them. Am I right? If they are able to find that yes, the lead was more than 2.5, then they will prove it that no, yes, that Maggie is not. So we were wrong in our assumption, we were wrong in our hypothesis. What we had assumed about that Maggie brand, they are the culprits because they are generating higher lead in that. Now this is something that is called as hypothesis. And now in order to validate that thing, right, in order to validate whether the Maggie has more than 2.5 parts million of lead in it, yes or no, for that we have to do something that is called as hypothesis testing. The test that you will do in order to prove whether your assumption is right or is it wrong, it is called as hypothesis testing. Correct? Now just all of you read this definition over here. Hypothesis testing is used to confirm your conclusion about the population, right? Over here we are talking about the population, which from the EDA or an intuition. Through hypothesis testing you can determine whether there is enough evidence to conclude if the hypothesis about the population parameter is true or not. Okay, we will use this hypothesis testing in order to prove whether we are right in our assumption or we are wrong in our assumption. Are we all clear on this? Now what we'll do over here is let's move ahead, right? So now this is the example that maximum amount of lead in any food product is 2.5 ppm, right? It is less than or equal to 2.5 ppm. Now this is something that is a general guideline that the Food Authority of India has given, and now they are assuming that any brand, any company which is manufacturing some food products, they should be following this. Okay. Now same example over here for the example of the court verdict. So there are two hypotheses that we have. Now if you see, one hypothesis that we have is, one assumption that I have is that the defendant is innocent, and the another hypothesis is the defendant is not innocent. Correct? Now this judge that we have, he is sitting with this assumption. Okay. And now this lawyer, he is trying to fight for this hypothesis. right? Am I right in saying that this judge is sitting with this hypothesis that he is innocent, and he is fighting to prove his hypothesis that he is not innocent, that means he is guilty. If he will be able to give the proof, then this hypothesis will be accepted, otherwise this will be accepted, right? Now this is what that hypothesis situations are. Now let's move ahead. Now just please don't go by these answers over here. Okay, no, actually I have these answers also marked over here, but based upon your understanding, just read the question and try to figure out the answer, right? So because you already have that answer in front of you. So the question says, which of the following is true about the two hypotheses that were just stated? So which of the following is true? Either one of them must be true or both must be true. It is possible for neither hypothesis to be true. It is possible for both hypotheses to be true. Now, how many conclusions you can have from here? Can I, so my conclusion will be either this will be true, right? Either this will be true or this will be true. It cannot happen that both of them are true. Can I say that both of them are true? He's innocent also and he's guilty also. No, that cannot happen. I cannot reject both of them, that he is not innocent and he is not guilty also. So at least one of them will be true, right? This is bound to happen. At least one of the hypothesis will be true over here. This is what I'm saying. Okay. Now, what we do is basically we divide these two hypotheses into two parts. We divide the hypothesis into two parts. First hypothesis is called as null hypothesis. Another hypothesis is called as alternate hypothesis. Okay, now these are the terms that we use in the statistics. So you have to be aware with this term. So now these are the technical terms of the statistics. What is null hypothesis and alternate hypothesis? Now null hypothesis is the prevailing belief about the population. It assumes that a status quo is true, right? So null hypothesis means this is that assumption, with the belief that the entire population is following that. It is that belief. So when I say that, say suppose if I say that the court example, so the court always sees every culprit as innocent. Now that is the prevailing belief about the population. We will always believe that my entire population is innocent. We cannot hang around or move around in this country by our assumption that everyone in this country is a murderer. Will I be able to move with that assumption? If I have that assumption in the country, will I be able to hang around here and there? No, right? Because if I will feel that everyone is a murderer, I will always be scared to death, right? So my assumption is that everyone over here is an innocent guy. Now that is something that is called as null hypothesis. The belief that we believe about the population that is true. All of you getting my point? And alternate hypothesis is something that is opposite of that, something that opposes the null hypothesis. So if I am saying my entire population is having an average salary of 10,000, now there is another guy who comes up, he says that no, Amit, what you are saying about the population, you are 100% wrong about that. The average population of in the average salary of an Indian is 15,000. He says to me this, that no, the average salary is 15,000. Now this is the prevailing belief. Now this is something that we were following for the last 5 years, that the average salary of an Indian is 10,000. Now randomly some person comes up and he says no, the random population, the average salary of an of India is 15,000. So now this will become a alternate hypothesis. Now if we will be able to prove this null hypothesis or this alternate hypothesis, if I will be able to prove this, that means I was wrong in my assumption. But if I will not be able to prove this, that means I was correct in my assumption, right? Getting the point? Okay. So now null and alternate hypothesis. The hypothesis you are trying to prove during the hypothesis testing. So which hypothesis do you try to prove? Is it the null hypothesis or the alternate hypothesis? Okay, so are you giving the answers by looking at the incorrect and correct, or is it you have understood it that why is that the answer? So why is that the answer? Why is the alternate hypothesis?
Can you hear me? Hello?
Yeah, Sahil, I can hear you.
Yeah, so basically, in null hypothesis, we are already assuming that it is correct.
Yeah,
Alternative hypothesis is taken to check whether null hypothesis is correct or not. So that is why we need to see whether the alternative hypothesis will be, we try to prove whether the alternative hypothesis is correct or not.
correct.
Just as you took the example of the case in a court, so the judge already assumes, or everyone assumes that it's the person is innocent until proven guilty.
Correct.
So that proving guilty is the alternative hypothesis in this case.
Definitely right. So yes, you're 100% right in your understanding. So is this so like so Nandini? So did you get this point? So it does not depends upon the data, right? So in every case, it will always be the null hypothesis that we will say that this is our general belief, and alternate hypothesis is something that we will try to challenge that. That no, you are wrong in your understanding, or you are not having the fair idea of what you are trying to say, right? So this is what, so always remember, alternate hypothesis is something that will bring the change in the world, right? If I'm already having an assumption about something, and that assumption would have been based upon the learnings of my last 10 years, correct? Now I have my belief that if I'll study hard, if I'll spend more time on my studies and everything, I will score higher marks. Now this is my assumption. Now there is a random guy, he comes up and he says, you are wrong in your assumption that without studying also you can get a very good job. Now that becomes an alternate hypothesis. Now he has to prove it. Now he has to bring few people or do something in order to prove that stuff. And now if he is able to prove that like, I hope every all of the people who are in this session, they all would have the same belief that the harder I will study, the better it will be for my career. Am I right? Do we all have the same perception that if we will study hard, only then we will be able to get the results, right? Now if someone comes to you and says that, okay, so Anchal, Jyoti, you are, why are you studying so hard, man? It doesn't make any sense. Without even studying hard, you can still, you can get the, the best of the jobs or the highest of the packages. Will you believe him? You will not believe him right away, right? You will say, okay, prove me, give me some evidence for that, right? If he is able to give you the evidence, then you might believe him that, yes, he is right what he is saying. Now this is the same thing that we have in the null and the alternate hypothesis. Okay, so are we clear on this? Now let us take a small example over here. Now say suppose, now I'm taking an example that, say suppose the average commute time of an employee is 36.5 minutes. Okay, so it was, we had actually kind of tracked down the data of the employees. Say suppose at the Ematicus, for all the employees, the data was captured in 2019, that how much time did they spend to commute to the office. Now I see that the average time that came out to be was 36.5 minutes. Now my null hypothesis will be that yes, okay, for every person that the average time is 36.5 minutes. But now uh, one of the employees comes in and he challenges it, right? That you are wrong in your assumption. That average commute time is not equal to 36.5 minutes, right? This is what he says, that your average time that you have calculated, that is incorrect. Now, when he says average time is not equal to 36.5 minutes, right? Are we all clear on this? How these two statements are created? One is null hypothesis, which was a general assumption that the time taken by the people is 36.5 minutes. So this becomes my null hypothesis. Now, alternate hypothesis will become it is not equal to 36.5 minutes. Now, what does not equal to 36.5 minutes mean? What is the meaning of this underlined word? Correct, right? So the time could be either greater than 36.5 or it could be less than 36.5, 36.5. Perfect, right? So it could be more or less. But we cannot say over here that it is less than 36.5 or more than 36.5, right? This is what we understand by this. So in the alternate hypothesis, we are trying to prove that it is either more than 36.5 or it is less than 36.5, correct? This is what we are trying to prove in this. Now this becomes our alternate hypothesis. Perfect. Now what we'll do over here is, I'll move ahead. Now let's just do this question over here. All of you please quickly try this. So government regulatory bodies have specified that the maximum permissible amount of lead in any food product is 2.5 parts per million, right? The maximum amount of permissible amount in lead is, what I can do is, now you will give me the answers. Now read the question. Now you have to give me what will be the null hypothesis. Okay, so Rishabh, you have given the right answer. So we have the correct answer from Rishabh, and we have Vishal has given the correct answer. Right, so Bhuvneshwari, you also have given the correct answer. Lead. So Sakshi, it is not less than, right? It is less than equal to. So my null hypothesis would be that the lead amount is less than or equal to 2.5, right, Surya, right? So that is what the null hypothesis would be. So let us see as, so the null hypothesis would be that. Now in this case, they asked for an alternate hypothesis. So what would be the alternate hypothesis? More than, right? So null hypothesis states, so if you see in the question we have, the question was related to the null alternate. So null would be, it is less than equal to 2.5 and the alternate would be greater than 2.5, right? Are we clear on this? Okay. Now if you see over here, so we define null hypothesis by H naught. Okay. Whenever we refer to the null hypothesis, we write it as H naught. And alternate hypothesis is something that we define by H1 or HA. Right. These are the small short forms that we use for these hypotheses. Okay, so when I'm saying conflicting hypothesis in criminal trial case, so null hypothesis that defendant is innocent and alternate hypothesis which is H1 or HA that the defendant is not innocent. Right? So these are the two hypotheses that we have. Am I right? Are we all clear on this? Okay. So now what we'll do over here is, if I just ask you over here, right? So now please all of you answer this question over here. Now these two pointers that are written over here, they are again, very important to understand from the way, from the context that how do we state the statements. Okay. So now, if suppose this is the null hypothesis, where I said that defendant is innocent. Okay, and the another case was defendant is not innocent, right? So this was the alternate hypothesis, this is the null, and this is the alternate. Now say suppose the lawyer is not able to give enough evidence, lawyer was not able to give the enough evidence to prove that he is not an innocent, that he has committed the crime. He was not able to give the he was not able to uh, he was not able to prove that. So what will you do? What will be your statement in that case? You will say, definitely you will say that accept null hypothesis. Will you say that your statement will be that I accept the null hypothesis? Am I right in saying that? Right? So if suppose the lawyer is not able to give that evidence that that the criminal has committed that crime, the criminal has committed the crime, so definitely the first hypothesis will be true. So I will say I accept null hypothesis. Okay. Now, when we say the term I accept, right? Accept means basically we are trying to say that, in under no circumstances that person has committed the crime, right? That means just I will like to reframe the sentence. When I am saying, when I accept null hypothesis, the meaning of that is basically that the lawyer failed to give any evidence in order to prove that he is not innocent, right? He didn't hand any proof. He didn't had any proof, right? The lawyer didn't had any proof, but that actually means that he was not a murderer. Can I say that? No, right? It could have been the case that there was still some evidence, but the lawyer was not able to detect that, or maybe lawyer was not able to present that, due to which his hypothesis failed, right? So that is why, when you accept the null hypothesis, you never say I accept null hypothesis. You say I failed to reject null hypothesis. See, the meaning is similar only, but the way we have conveyed this thing is a little different. So I am saying I fail to reject null hypothesis. I fail to reject null hypothesis. That means I accept null hypothesis. Are we all clear on this? Just go by the statement. It is just a simple English, the change of the words. So if I say I like you, or maybe if I say I don't like you, I am saying it in the way I fail to say I like you, right? So it's just the framing of the sentences that has changed over here. So instead of saying I accept null hypothesis, we actually use the term as fail to reject null hypothesis, because every statement will be in the context of the null hypothesis. Okay, every statement will be in the context of null hypothesis over here. So if in case you find out that evidence that that the defendant was not innocent, that means you are saying I reject null hypothesis. What your assumption was, I reject that. Getting the point? So if you will say in both the cases we are using this term null hypothesis. Why so? Because null hypothesis is our prime, the base on the basis of which we are doing the test, because this was our the long lived the assumption about the population. So when I was not able to find enough evidence for this, so I'm saying reject null hypothesis. In the other case, I'm saying failure to reject null hypothesis. Correct, class? Okay, see what I am doing over here is, so Rishabh, like basically what I am saying is कि मैं ये कह रहा हूँ कि देखो, अब अगर आप सपोज करो आपका ये नल हाइपोथेसिस था, आपने बोला कि जो मुजरिम है वो इनोसेंट है, वो आपका नल हाइपोथेसिस है, वो आपकी एजम्पशन है कि मैंने उसको मान रखा है कि वो उसने क्राइम नहीं किया. ऑल्टरनेट हाइपोथेसिस क्या बना आपका कि उसने क्राइम किया है. करेक्ट? अब दोनों में से एक चीज होगी, या तो उसने क्राइम किया होगा या नहीं किया होगा. अगर सपोज करो उसने क्राइम किया है, राइट, अगर उसने क्राइम किया है, तो उस केस में कौन सा वाला हाइपोथेसिस ट्रू हुआ आपका? कौन सा हाइपोथेसिस ट्रू हुआ? नीचे वाला. नीचे वाला, ठीक है. आपका सेकंड वाला हाइपोथेसिस ट्रू हो गया कि उसने क्राइम किया है. तो उस केस में आप क्या बोलोगे? बेसिकली आप ये बोलोगे कि मैं आपका जो assumption था उसको रिजेक्ट करता हूं, ठीक है ना, उसकी बात तो वही हुई ना, उसका मतलब भी तो वही हुआ ना कि आई रिजेक्ट दिस, मैंने इसको रिजेक्ट कर दिया, मैं इसको रिजेक्ट कर रहा हूं। अगर मैं इसको रिजेक्ट कर रहा हूं तो उसका मतलब क्या है कि मैं इसको एक्सेप्ट कर रहा हूं, राइट? अगर मैं इसको रिजेक्ट कर रहा हूं, मैं चाहे बोलूं कि मैं इसको रिजेक्ट करता हूं या मैं बोलूं मैं इसको एक्सेप्ट करता हूं, दोनों का मतलब तो एक ही है ना, मतलब तो एक ही है। तो उसी चीज को मैंने बस यहां पर लिखा हुआ है, रिजेक्शन ऑफ नल हाइपोथेसिस, मतलब कि दिस इज ट्रू। व्हेन आई एम सेइंग फेल टू रिजेक्ट नल हाइपोथेसिस, मतलब दिस इज ट्रू, दैट्स इट, सिंपल। मतलब इंग्लिश में थोड़ा सा बस वर्ड्स को हेर फेर करा है, उसके अलावा कुछ नहीं है, ठीक है, दैट्स इट। जैसे स्टेटमेंट को आप रीड करोगे तो दैट इज द मीनिंग ऑफ दैट इज, जस्ट डोंट फील बाय दैट अजम्पशन की बॉस ये स्टेटमेंट मेरे समझ में नहीं आ रही है, कंफ्यूज हो रहा, तो मुझे हाइपोथेसिस समझ में नहीं आया। हाइपोथेसिस आप लोग सबको समझ में आ गया है, इट इज जस्ट दैट द टर्मिनोलॉजीज दैट वी यूज टू एक्सप्लेन दैट इट इज लिटिल डिफरेंट। Yes, so Rishabh, we are using the same term, right? So we are using null hypothesis in both the statement. If you see, because our conclusion is actually dependent upon the null hypothesis. So if you will see, null hypothesis is coming in both the statements. Over here also you have null hypothesis. Over here also null hypothesis only. So if we are accepting this, so I am saying rejection of null hypothesis. If I am accepting this, so I am saying fail to reject null hypothesis. That's it. Okay, class. Are you all sorted on this? Anyone still having any doubts? Harmeet, Bhuvneshwari, Akshay. Okay. So now the fun part will start from here. Okay. Now you say that, like this is something that I was trying to explain, that we never say accept null hypothesis. We simply say failure to reject null hypothesis. That was the same statement that I was trying to explain you in the previous slide all the time. Okay. So over here, now read this question over here now. Just do this. In the Maggie noodles example, if you fail to reject the null hypothesis, what can you conclude from that? अगर आपके मैगी वाले केस में you fail to reject null hypothesis, उसका क्या मतलब होगा? That is more. More कैसे हो जाएगा दोस्त? It cannot be more. आपने क्या कर रहे हो? आप fail to reject. आपका null hypothesis क्या था? What was your null hypothesis? Null hypothesis was your assumption that the lead is less than equal to 2.5, right? And if you fail to reject null hypothesis, that means your answer is less than 2.5, right, Swati? So your answer is correct. Sahil, you are correct. So your was wrong. Rishabh, you were wrong. And then Subhakaran, yes, your is right. Right. So all of you, most of you have given it right. Naveen, your is wrong. Bhuvneshwari, your is also wrong. Rishabh, your is also wrong. Right. The people who actually said very actively that it is correct, we have understood they have only given the wrong answer. Okay, now is it making sense? So it was just a game of understanding the statement. That's it. Okay. So now, so the null and alternative hypothesis divide all possibilities into how many parts does the null and alternative hypothesis divides our the assumptions into, right? Which also it is 2, right? And can they overlap each other? Can those two things can they overlap on each other? Can they be the outcomes can be overlapping? No, right? The outcomes can never be overlapping, right? Okay. Now what we'll do over here is, so now we will try to understand this thing and we will try to see its, the practical usage of this hypothesis testing. Okay, we all have understood its theoretically what they are. Now we will try to understand it, because we also have to prove that. Right now, anything that we will be proving, that will be statistically, right? Over here, definitely over here in the data science, we will not be trying to solve the cases of the code, that whether the culprit, that the criminal who has been held, is he guilty or not. Definitely we are not going to do that. Our assumptions and all our analysis will be related towards the data related problems over here. Now just read this question that you see flashing on your screen. You just have to read this question over here. Now, the first step of hypothesis testing is the formulation of the null and alternate hypothesis, right? So before you start any of your hypothesis testing, the first stage of that is you have to define that what will be your null and what will be your alternate. Okay, only then you can go ahead. Okay, now we will understand this thing with the example. We will take an example of a AC company. We have a AC company. Say they say that the average sales of AC per store per month is 350 units. Okay. Now they analyze that from the last few years, that the average sales of AC per store per month was 350. Now the team is claiming that now the weather has changed, and this time the sales will not be equal to 350. Okay, now they are claiming that the sales will not be equal to 350. Now this is the question that we have. Are you all clear on this? This is the question that we have. Now they said that in the last few years the average sales of AC per unit per store per month was 350. Now they are saying the weather has changed and the sales will not be equal to 350. So now tell me what will be the null hypothesis and what will be the alternate hypothesis? So Harmeet, your answer is wrong. Please try it again. Yes. So Sakshi, Bhuvneshwari, your answer is correct. So, but your alternate hypothesis is wrong. Bhuvneshwari, your alternate hypothesis is wrong. See, where does it says that alternate hypothesis should be greater than 350? Now the weather has changed. The weather can be changed for good also and for bad also. Now say suppose the weather has changed. Now the weather will not be that hot. So will in that case will the sales be higher? Right? In that case the sales will be low. And in case the weather becomes hotter, definitely the sales will be higher. So we do not have information about that weather, but we have that statement over here, right? So my null hypothesis will be that my AC sale is equal to 350, and my alternate hypothesis will be it is not equal to 350. As simple as that. Correct? Because it is everything is written in the statement also. Sales will not be equal to 350. So it nowhere says it will be more than 350 or less than 350. It is simply saying it is not equal to 350. So if I see now, so my the null hypothesis will be H naught is 350, assuming that the status quo is true. That means sales will be the average sales will be 350 per units. And my alternate hypothesis will be that it is not equal to 350. That means the status quo. See, status quo का मतलब क्या होता है? What is status quo? Status quo means the same situation that we had yesterday. The same situation we will have today. That is what we understand by status quo. And these days this term is used a lot, right? When this lockdown period was going, you all would have heard this term, this term a lot in the newspapers. You might would have the people who are, who read newspapers, they would have seen this term status quo in the newspaper a lot. That Delhi state to maintain the status quo. That means the kind of lockdown, the that the conditions were there. They will remain the same as of today as well. We used to see and hear this term a lot over there, status quo, that the state to follow the status quo. Okay. Now again, I have a question for you all. Right. So Flipkart claimed that its total valuation in December was 2016 was 14 billion. What would be the alternate hypothesis for this given situation? What will be the alternate hypothesis in this case? Not equal to 14 billion, right? So it is not equal to 14 billion. Correct. So Sahil, you have given the right answer. So we have, who all have given the right answer over here? Okay, Vishal. Correct, correct, right. So you all have got it now. Now let us understand it further. Okay. Now over here you will see that in the previous example what we saw was that when we write the null hypothesis, we kind of easily from that claim statement we can identify that what was the status quo and what was the alternate hypothesis, right? But in some instances, right, if your claim statement has words like at least, okay, now just read this. I will just give you all 2 minutes to just read this up, and I'm pretty much sure that you all will be able to understand it. Okay, so Vishal, you have got it. Others? Oops. Yes, yes, just like the case of the Maggie, right? All of you, are you all able to understand this? Because if you all have understood this, you will be able to do the next question as well. So the key takeaway from this slide is, the key takeaway from here is that null hypothesis always has this equal to or less than equal to or greater than equal to. And alternate hypothesis will have either this or this or this. Correct? These are the key takeaways that we have from here. Now let us see who all have understood it. So now this is the question that you have. Now tell me what will be the null hypothesis and what will be the alternate hypothesis. So Vishal, please define it properly. So so you are saying null hypothesis, right? So null hypothesis is saying less than equal to 14 billion. Is that what you are saying? Correct. So Sakshi, you have no. So Vishal, your output is wrong. What you have mentioned. So Yash, yours is correct. Rishabh, yes. Prerit, yes. So right from here we can see that we have a greater than equal to sign. So my null hypothesis is that their claim is that they had at least 14 billion. That was the bare minimum. But the null hypothesis will be that null hypothesis will be more than. So it will not be less than, it will be more than. When I say at least, so it is like, if I come to your home and you ask me that Amit, how many chapatis will you eat? I will say at least I will eat 2 chapatis. Right? So that means कि दो तो खाऊंगा ही खाऊंगा. 2 की 3 भी हो सकती हैं, 4 भी हो सकती हैं, पर 2 से कम नहीं होंगी. Right? That is what we understand by this. The at least. Okay. So this is what the answer was. So we had the null hypothesis greater than equal to 14 billion and less than will be my alternate hypothesis. Okay. Now do this. सबके गलत है, सबके आंसर गलत आए हैं यहाँ पे. See, all of you have given the wrong answers, although the answer was written over there in front of you itself, right? So what is the thing that you read in that slide? So the statement that we read was ki, that if you have a null hypothesis will always have a sign like this, right? Null hypothesis is something that will always have a sign greater than equal to, less than equal to, or equal to. Okay. Now when you have given me the output h naught is greater than equal to 14, where is it written that it is greater than equal to 14? Where is it written greater than equal to? How have we got that equal to sign from here? The statement is saying greater, right? If I am saying मैं रोटियां 5 से ज़्यादा ही खाऊंगा, I will eat more than 5 chapatis. Does that mean I will eat 5 also? It simply means it will not be 5, it will be 6, 7 or 8. I will eat more than 5 chapatis. Right, that is greater. But when I say I will eat at least 5, so minimum 5 or 6, 7, it can be 6, 7, 8 as well. But if I say I will eat more than 5 chapatis, so nowhere I am saying that I am gonna eat 5, right? It will be 6, 7, 8 or 9. Correct? Am I saying is my saying correct over here? Okay. So now because in the statement I have a greater than sign, so what will be the opposite of that? Opposite will be less than or equal to. Am I saying in that? अगर मैं बोल रहा हूँ मैं 5 से ज़्यादा खाऊंगा, तो दूसरा सिनेरियो क्या है कि if I'm saying I will eat more than 5 chapatis and my brother says whatever my brother will do, I will do opposite of that. So he will say if he will eat more than 5, I will eat either less than or equal to 5. Because even if I eat 5 also, still I am going in the opposite direction of him. Correct? So my inverse becomes less than equal to. Now less than equal to is coming in the opposite statement of this. So because in that slide you read that the null hypothesis should have a equal to, less than equal to, or a greater than equal to. So my null hypothesis will become that the valuation will be less than equal to 14 billion. And my alternate hypothesis will become it is greater than 14 billion. Okay. So no equal to sign, this becomes my null hypothesis, and the other one I have it as a this is the alternate hypothesis and this is the null hypothesis that we have. Okay, are we clear on this? Yes, class. Can I have a yes, no from all of you? Okay. Anyone with a no over here? Okay. So Sakshi, like when I asked, when we were reading this slide over here, right? So when we were onto this slide, just see these points over here. So it is written, these are the rules that you can use to formulate the null and alternate hypothesis. The null hypothesis always has the following sign: equal to, or less than equal to, or greater than equal to. And alternate hypothesis is something that will have the sign not equal to, greater than, or less than. Okay, is this correct? Now please keep these pointers in your mind. What is the claim over here? What is the claim? What is the company claiming? Just read this, that in December 2016 the total valuation in 2016 was greater than 14 billion. What is this statement? Greater than 14 billion. Correct? This is what this statement is, that the valuation is greater than 14 billion. Okay. Does this have a sign equal to, greater than equal to, or less than equal to, or equal to? Does this have that sign? Any of these three signs? Do I have any of these three signs over here? No? Sakshi, do I have any of these signs in this statement, in this claim? Any of these three signs? No, we do not have, right, Bhavani? We do not have. It is greater than. And another sign that we have is that it's greater than equal to. So that these two signs are different. One is greater than and one is greater than equal to. They both are different. If I say you will get a salary more than 10,000, so that means your salary will be more than 10,000. It will not be 10,000. But if I say your salary will be greater than equal to 10,000, in that case you can have 10,000 also as a part of your salary, right? So these two signs are different. So in the null hypothesis, we should have any of these three signs. But since we do not have that equal to sign over here, so what I did was I created an inverse of this. I created an inverse situation. Okay. So if one claim is, the claim is it will be more than 14 billion, what will be the another claim? What will be the opposite of this? What will be the opposite of more than 14 billion? It will be less than equal to 14 billion, right? It will be less than equal to 14 billion. That will be the opposite of this. Now in this, since I have less than equal to sign, and the less than equal to sign has to be a part of null hypothesis. So can I now say that this becomes my null hypothesis, this part over here? Can I say this? Okay. So this is how we are defining. This is your alternate hypothesis which had greater than. This was the something that was given me in the statement, but because this didn't had no equal sign, it doesn't have any equal to sign in this, so that is why I had to make it alternate. And you see in this, since I have a equal to sign in this, so this becomes my null hypothesis. Okay, now you can just try this out. I can just maybe, yeah, so we can do with this. Yes, Sachi, so your answer is correct. So Vishal, your answer is wrong. So this is the same thing that we were discussing. So null hypothesis should have a equal to sign, right? So your symbol doesn't have that equal to sign. Swati, your is incorrect. So the question says that the Goodyear is claiming that their tires will have mileage more than 7,500. They are claiming it will be more than 7,500. It nowhere says that it will be more than equal to 7,500, right? So they are saying over here that their mileage will be more than 7,500, which means more than 7,500. Okay. Now, can this be a null hypothesis? Can I call this as a null hypothesis? Yes, Swati, can I call this as a null hypothesis? No, I cannot, right? Because this is something that I was explaining you, right? So your null hypothesis should have a equal to sign. I do not have a equal to sign in this. So this cannot be a null hypothesis. Null hypothesis is something that should have a equal to sign. So in this case,
Sir,
yeah, Naveen?
sir, whatever is claimed, is it sure that it always would come in the category of unknown hypothesis?
Sorry, whatever is
Sir, whatever is claimed, is it whatever is
whatever
claimed,
claim, yeah.
whatever is claimed?
Huh?
Yes, sir. Whatever is claimed, is it alternative
No,
hypothesis?
no. So in the starting, how did we started this entire session?
Yes, sir.
We started the entire session that my claim was that my bid in the bank less than equal to 2.5. So in that case, my null hypothesis was that the claim that I had given.
Yes, sir.
Okay. So null hypothesis is
Okay, sir. Okay,
something.
sir.
Null hypothesis
Got it.
will have a equal to sign. That is mandatory. That is a mandate. Now in this case, is the claim is that it is greater than 7,500. It doesn't have a equal to sign. So it will become a alternate. And my null hypothesis will be it is less than equal to 7,500. That will become my null hypothesis. Okay. Yes, class. Are we all sorted? Anyone still having any doubts on this? Okay. Perfect. So now you know because up till here we have just understood how to create the hypothesis. So in tomorrow's session we will be learning on how to prove our hypothesis, right? So how do we actually prove it? That whatever claim there are, how do we come to a conclusion where we can say that our claim is true or not, right? So this is something that we will start off tomorrow. So please go through these things. I mean, I'm not sure if the video will be uploaded by today, and so just try to go through it. I mean, whatever you are able to retain. So just go through it and we can discuss any of your queries and questions in tomorrow's session. Okay, class? Yes, Rishabh. So this is correct. So H naught will be less than equal to 7,500 and H1 will be more than 7,500. Okay, class. So see you tomorrow. Thank you. शक्ल है मार्क में उसके उतार कर शक्ल ही अलग से दिखती है एकदम से करते हैं अभी स्टार्ट